Good morning, everyone. We're back. Hopefully you had a good time yesterday and today as well. Lisa is coming a bit later, but we'll talk about things here and have some coffee. So have your coffee ready as well. So we have about 9 people here, but hopefully you will get crowded fast. Morning. Good morning, everyone. If you have any questions at the moment or anything you want to discuss, we can discuss it now. It's a good time. We have about an hour for that. Just gonna check that this is coming live on YouTube as well. I think it is. Okay, it is. So if you're just connecting, we're just chatting for now, and you can see the schedule here at the America's schedule. I'll just post it for you. And the idea today it's to have the train track and the hack track, of course, as always. We'll have more Q&As today, so if you have any questions, you have more time to ask them. Especially the newbies, they will. I think people were having some problems getting into other projects and all that, and so I want to hear about that too. Want to hear what your problems were. Let me just. There was a poll that we wanted to ask people to fill up, so I'll do that now. So just a summary. So today I will just talk about that. So right now we're at the coffee, breakfast, lunch. So you can also go to the Gather Town. I'll just post the Gather Town link in a bit. And so you will receive the poll by email at day 3. Okay. So okay, I'm just getting the poll now. I think you can answer the poll now. It's about your experiences now at the hackathon and how can we improve it. So later today, in 1 hour, we'll have the daily presentation and of the train track daily intro. It's about 15 minutes, and then so we'll talk about some things that we need to talk about, and then at 10, well, my 10:15, I think it's 9:15 for most of you. There will be the train track hack track. So we'll have the MATLAB train track, the MATLAB talk with Aga, and then we'll have the benefits of bits, and then we'll have a talk about that's the unconference that will be used by the CONP about introducing a platform from the open sharing of data and pipelines. So that's for the Canadian Open Neuroscience platform. And then we'll have the talk about Data Lab, which I think it's a really good talk. You should be on. Hi, Sanu. Morning. And then we'll have the daily wrap up. So there's a lot of talks today, a lot of people that should go in, especially newbies. But feel free to ask us questions and everything. We'll have a lot of Q&As today. And there was a lot of people that wanted Q&A, so I think we're going to have that. So I'll put the small post here. See if I can manage it because I haven't used this before that much. Yeah, here it is. So here's a small poll that you can answer. It's just right below me here. So just answer it if you can. There were people yesterday that had problems with Mattermost. So just let me know if you still have that. Morning, Remy. Things are good. Starting slow. Yesterday by now we had like about 80 people or so connected. Today it's 14. I think people are tired, which is understandable. So, but I think everything's good. How was yesterday? You wanna come in and chat, or waiting for Lisa to? Oh, she's here now. Okay, let me just invite you.
Good morning.
Hi.
Hey.
How's it going?
Hello.
Remy, you invited me to the chat during the EMEA session. Well, I don't know if it was you or Camille or Salim.
No, I think it's Salim who must have invited you.
I was still in my pajamas and I'm like, no.
It's like, yeah. Actually, yeah, that happened to us this morning here, where started inviting people in the chat. They were like, oh yeah, I actually invited Camille, and she was like, give me 2 minutes, I'm not quite ready. Same with a couple of like ladies were just like, wait, I still need to sort of like figure out where my brain
Looks
is.
somewhat presentable.
Exactly. Yeah.
Cool. I'm gonna. Oh, I think Eduardo. I think you're the only one who can add like action items.
Yeah.
Can you add a button for Gather Town?
Yeah, sure.
Or maybe people know where Gather Town word is. Maybe you don't. That's fine.
It's a sure? Yeah. That's the poll is there right now. I'm just going to look for the link for the Gather Town.
Okay. Cool. We can add the poll again during the intro session then.
Sure.
Is that the poll that?
Oh, I wonder if that's just happening with Framaform, because I tested the form yesterday when it was just a Google form.
Thanks,
and it was fine then. Yeah, thank you.
We'll have to check that.
That is annoying.
So here's the link for GatherTown, in case people want to go in again.
Yeah.
Have a morning coffee. Talk about bagels again. or other desserts.
I once again have not had breakfast yet. I was about to, and then I'm like, oh, I need to do this now.
Too late.
You can go. I mean, it's not a problem.
No, it's fine. I'll do it. I'll do it during the next train track session. That's the plan.
And there's a lot today. So I was just talking about the whole schedule, but we have a small audience, so I think we can wait for important stuff when in about 50 minutes.
So Remy, I was gonna say Remy, your hub apparently went great today. You were saying.
Yeah, it was very smooth. I think that our broadcast team, like Annabelle, Ishil, Sophie, and Selim, worked on trying to make sure that the videos would run just well. You guys had no problem yesterday, but that was not the same for us. And today was just very smooth, I think. So we had it was easy to have like Q&A after each video. It was a bit it was okay. The tip I have was that because you can't really introduce a session at the big, like a video at the beginning of a session, because the person hosting the show cannot. You can have several people on stage and just talk about it. So usually what I would do is introduce one session at the end of like you introduce like the train track at the end of like the Q&A of the previous one. So that you go like, hey, now we're going to talk about this, and then that can make for a smooth transition. And then, yeah, it was good. I think as well that most people knew where they were going now.
Okay, perfect.
People were less confused with the different platforms. They sort of like, oh, I know this environment now. Compared to day one, where the number of messages in all the channels was just
overwhelming.
No idea what was going on. Like today, I was like, oh, this is quiet. I was like, is this okay? Like everyone left. Bless you.
Yeah, thank you.
So yeah, no, it felt like it went pretty smoothly, and I heard the same from APAC. I think that in Asian, they had a good day. Angela was telling me that she had a lot of fun just like hosting that today. So it was it's been great so far.
Awesome. Angela, do you want to come on screen?
Yay! Come on, just like yesterday.
Yes.
So we have like the four hosts on the same chat.
Let me just get her here.
Cool.
So right now I just downloaded both media to actually play videos with audio. Hopefully, if we need it, it will work this time.
Cool.
Hey.
Morning.
Hello.
Evening for you.
So, yeah, true. It's pretty late for you now.
Yeah, what time is it?
Too late. It's only 10 p.m.
Oh yeah. Okay. I've been sleeping like 4 or 5 hours the past few days. I guess, Remy, I'm living your life.
Yeah, don't know. I'm a very bad example to follow. Don't do that.
I've been finding it so hard to sleep though. I'm just like, but the hackathon, I have to be up. Things have to be done.
Yeah, you need to sleep, otherwise you're not like clearing the amyloid from your brain, and then you get Alzheimer's disease.
Angela, you don't need to teach me about Alzheimer's disease.
Just a reminder.
Thank you. Oh my god. I was literally working. Well, one of the reasons I was up late is because I was working on my poster for OHBM, which is literally on amyloid beta and Alzheimer's disease.
Wait, for OHBM, did you get an extension somehow?
No, I'm just gonna.
I'm just gonna try to squeeze it in.
A little birdie told me that it might still get accepted before by the 19th. But also, I really hope nobody like affiliated with OHBM like officially is actually on this track. So I uploaded a link to a Google slide, which I will then just update worst case scenario. We'll see.
Okay.
Yeah.
Okay, that's not bad.
I've seen that discussion where people were like, yeah, this should be okay.
Well, it's like it's a participant list.
I'm glad it's only 27 people because I sound like the most irresponsible human right now. Please don't take my example.
No, that's fine. I'm just using technology to your advantage. That's fine.
Yeah.
Well, I mean, to be honest, what I did on my poster was add a link to a Jitsi room, going like, "Hey, want to chat live? I'm here."
Oh, that's smart, actually. Yeah, honestly, maybe I should have just done that.
I mean, the deadline was such short notice. Like, it was, pretty crazy. So.
And I don't really know that the 4 days would make a huge difference anyway, because I mean, like, I commented on a pre-existing post on Twitter where somebody was like, hey, all of my grad students are panicking because you've now given us just like a 4-day notice.
Yeah.
Right.
And they were like, nothing we can do. Communicate decided that we have to have everything uploaded so they can deal with 2,100 posters. But I'm like, I mean, is it that much extra work? I don't know.
Yeah,
Anyways.
I don't know.
At some point, I had trouble with the login in order to upload the poster, and then I was just like, oh, it's a universal login. What if someone changed the password like in protest or something?
Actually, though, you guys didn't hear this here. Angela said nothing. Don't get any
exactly.
ideas.
I have no idea what you're talking about.
I don't know.
Connection
yeah,
issues.
okay, I'm just like spreading fake news. Like, it was just something that came into my mind. Like, I'm not saying I was like, I did this or anybody did this. FYI.
It's like an open science uprising. I love it. It's great.
You guys hear me?
Yes.
Yep.
Yes, okay. I just did something and it broke things, but now it's good.
No,
didn't notice.
Loud and clear.
Yeah.
Good.
Cool.
No, I just installed this whole thing just to have the video playing with the audio. Now I think it should work, hopefully.
Okay.
But I don't think we needed that much today.
Yeah. Well, because now we have things set up with OBS, so I think it should be fine.
Mm-hmm.
Hopefully.
Yes.
It went pretty well yesterday.
Yeah.
Oh, actually, I guess question for Angela and Remy. Did you find that people were a bit... I enjoy the look, Remy. What do you want from me?
Exactly.
Were people burnt out, did you think, from like all of the train track sessions we bombarded them with today?
On day 2?
There's quite a bit. There's MATLAB, which is like 2 hours long. There's DataLad, Bids and Bids apps.
Let's see. So DataLad was the quietest session for me. So I kind of wonder if it, because it was like the last one too.
Yeah. Okay.
But the first 2 sessions were really good. Like, people were definitely into it, especially the math one.
Yeah, I have to check because you had Orina who did that, right?
Mm-hmm.
Had,
yeah.
I guess a talk on this. Yeah, and I think she posted a link to a Medium page, right? I think about.
Yeah. Mm-hmm. With like tips.
So I'll have to check that out. I know that people were pretty active on the one by Agadas for sure. Bids, I think people were a bit active on. I think for DataLad is a bit less known yet, so I think that's why people were a bit more quiet. But I think we're getting a lot of people who are used to deal with like very big data set going like, you need this, like trust me. So that people were like, oh, okay, maybe I should pay attention.
Also, for those of you who are currently online and watching this, there are bunnies in the DataLad video.
Yes.
It's really great.
It was.
Yep. Definitely, that got a lot of attention. People were really just like, "Well, what's going on here?" Yeah, that was definitely awesome.
Yeah.
No, but I don't think that there was. But then again, I mean, I'm talking from my perspective, and I've seen some of those videos before, so it's kind of hard to tell.
Well, I think in general it's hard to follow up, right? I mean, online. I think in general. You get tired after some hours.
Yeah.
Definitely.
For sure.
Yeah.
So are we having this videos somewhere? I mean, the recordings?
Yes, they will be
People were
online.
asking.
Yeah. So some of them have already been put up by the train track instructors themselves. So I know that Adina, for example, has already put the DataLad video on YouTube. Stefan Bowman and Saskia just put their GitHub stuff on as well. Sam has put the bids video somewhere as well. I can't remember the link from the top.
And his repository. Yeah. I mean, they're all public.
Yeah. The idea, I think, in the end, is that we'll try to just make nice playlists on YouTube of all those videos in the end, but we haven't sorted the sort of agreeing with all the train track instructors about how we want to share this and everything. So we'll try to curate things first, and then we'll put that in format.
Great.
You can just like watch all of them.
Great.
Yeah.
Maybe add some of the crowdcast stuff as well if we are all okay with this. We'll have to figure out how to do that.
Yeah, for sure. Cool.
Yeah, but
so
that will be available. Yeah.
we can also talk now with project managers that to see their experience at the moment, or people with more experience. Just to, because newbies sometimes get lost in this, so perhaps it would be nice to have a talk with them now, and
Yeah,
maybe we'll also
I'm just gonna get by.
Yeah.
And I'm gonna try to have like a couple of like minutes of sleep, and then
Yes, please.
yeah.
Wait, Remy. Have you had food today?
Yes.
Wow.
Yes.
Good.
Actually, that's pretty much that's what I said in my wrap-up session today, and I actually even tweeted about that. Pretty much, I was like, your event is doing okay if the organizers have time to eat.
Yeah.
I have time to eat, so I think
Good.
we're doing pretty good today.
Great.
That was,
right.
yeah. Good.
Thanks a lot.
So that was But okay. Anyway, I'll leave, and you get your project leads on stage so they can tell you what happened yesterday.
Great.
Perfect,
Thanks.
yeah.
Bye.
Bye, Remy.
Bye.
So who's here that can talk? Maybe Sanu wants to talk, or
Yeah, sure.
I don't know who else is project manager.
Project manager.
Well,
you
I
mean
guess
project lead?
project leader. Sorry, see.
I see Pradeep is online.
Is he? I haven't seen him.
Looks like it.
It's not live now. So let me just write this down.
Yeah. Oh, Angela, I only discovered the little the little food section of GatherTown with a bagel stand after you posted about it on Twitter.
It's actually a pretty big virtual room, which is funny, right?
Yeah.
Like I know the tour of it, and I was like, oh, this is gigantic. Who designed this? Like, it's hilarious.
It was Johan, I think, or what's his name? Yeah.
Johan, yeah. I think I just saw his name, that he's online.
Yeah. You can see there's the room that says hackathon something, hack room, something like that.
I just loved all the detail.
So no one's here apparently.
Yeah. I mean, I guess, we could go into GatherTown, but we learned yesterday that it's a bit difficult to do both GatherTown and this.
Yes.
Right, yeah.
People were asking me, your mic is up. Your mic is up. No, I'm talking somewhere else. Yeah. So maybe you can go to GatherTown if you want. And I can just stay around here.
Sure, I can do that. Okay, I will go into GatherTown.
I will know you're in there. So if you're talking and your mic is off. Cool.
I mean, I'll just close my video for now then.
Sure.
Cool. All right.
Sure.
See you soon.
See ya. So how was day one for you guys?
It was good. I think at the beginning we had some problems with the video, but I think you saw. But otherwise, I think it was fine. But we did have some people that couldn't connect to Mattermost, like their email wasn't working. You also have Mattermost in Asia, right?
Yeah, I'm on it.
But some people said that, and more than 5 people said that they weren't getting the email back, the registration email from Mattermost, so they couldn't connect to Mattermost.
Oh, that sucks.
So there was no way. Yeah.
Yeah, shit.
They couldn't be in the projects because of that, and I don't know if that fixed. People can come up and say if that was fixed. Other than that, I think it went well, but I think there was a lot of people that knew people that weren't involved in projects because they didn't know what to do, how to get in. Mm-hmm. Some people saying that, you need to code, and I don't know how to code that well. And
right.
Mm-hmm.
I mean, that's definitely a recurring theme for first-time hackathon people.
Yeah.
They don't always feel intimidated about I don't know if I can code well enough to contribute and stuff.
Mm-hmm. Yeah, but we're also saying that some of the projects don't need coding, so the leads should advertise that.
Yeah, for sure. I definitely agree. Yeah, I wonder if there's just a way to advertise that more, to be you don't necessarily need to have coding experience to partake.
Yeah. I mean, I guess that's the problem when you enter the hackathons, right? I mean, the first time I went into one, I didn't know what it was. I just went with it.
Yeah, it was actually really hard to recruit people to like join in over here, just because like a lot of people weren't really familiar with what a hackathon was, and then you kind of describe it, and then they're like, I don't know, it sounds kind of like a waste of time, and I'm like, no, it's fun, and you can meet a lot of different people, but then they're just kind of like, okay, so you're working on a project for 3 days, how far can it possibly go? And
yeah,
I don't know.
I mean, can you talk about your experiences? Because I think people want to know about that, like experiences with projects within hackathon and how long did they go? There was some questions about that yesterday.
Mm-hmm. I think it's a really good experience in making new connections, and you don't necessarily finish a whole project from start to finish in a 3-day hackathon, but you can get a lot of work done, and then you can carry it on later, and that can result in a lot of cool things, like a new tool or like a publication maybe, so there's a lot of benefits to it.
I feel that you also get to know people a lot, like especially in research, right? I mean, you're with them like maybe even 12 hours for the whole day, like 3 days in a row, and that I mean, if it's a good collaboration, you will maintain it afterwards. That's my experience, at least.
I was having this conversation with one of my friends. Maybe he's actually in Sebastian.
Ask him.
He's here. I don't know if that means he's like around, but
Sebastian who?
Works.
Let me see. I don't see him.
And he told me he was like thinking of pitching a project, but he wasn't sure like if it was at the right stage in order to be pitched and stuff. And yeah, so I feel like some people definitely have an opinion on like, if it's like at what stage to pitch a project. Like if it's like really brand new and lots of people can contribute like a lot of different ideas to something that's not exactly like started yet, then that could be really good because lots of people can contribute really quote easily in that scenario. Or if you're like really close to kind of like finishing something and there are like very concrete steps that you want to like finish up and be like, this is what we need, and this is really what we're working on. So it's like really like a sprint during the hackathon to get it done. And so then Sebastian was like, well, for my project, I just feel like it's kind of in this like weird between stage where like I'm not 100% sure like what it is that I do need or want to do for it and stuff.
But I mean, I guess you can also, I mean, even if people don't code, I mean, having new ideas would be good to have. That's also hacking. I mean, in my book,
definitely,
to contribute with ideas and maybe if you're stuck with a project, that's also good. I think everyone's. I mean, I've been stuck with projects. I stuck with projects all the time, and I think it's great if you have like input from people that are and have different expertise, different opinions.
Yeah, for sure, and it's always definitely good to have someone else look over your code too.
That too. Even if you feel like they're exposed, but I think in my experience it was really good in the sense that so you learn things, but at the same time you're doing things and feel. I mean, at least in the one I went to it felt very organic. Maybe now it's more like virtual. It's not that. It's a bit difficult. But I mean, I guess a lot of people will feel like it's a more organic way of working, and then you can just do research. I think that's the point, right? But there was I mean, in this time, for example, there was a lot of projects with coding. I would say, which I have the experience of having project without that much coding, or half coding, half other things. So I guess we should invite people to actually put projects that are not especially coding, because hackathon usually what
like a good project would be like documentation. There's not enough like emphasis or importance placed on documentation, but like it's great, and for someone who's not super strong at coding or whatever, like that's like actually a great project to do, and it's really useful too, like really useful.
It is. The last hackathon I was in London for the Primate there's a primate group. I work with a lot of species, but I went to that one and it was really good. And there was a project from two colleagues that they basically did a website for all the tools for primates, because there wasn't any. So after that, right now they're going to publish it as a paper, but there's I think about maybe 10 or 15 tools now, and all of them in the website, and you can just, it points to the GitHub for each one, and that's huge. That's a huge help.
Great resource.
Yeah. So I mean, just small things like, I think people don't realize that you can do small things like that are actually big. They look small, like documenting, making a website. But I think it's a big thing. But people are shy, I think, also because if you don't know how to code very well.
Yeah. Well, everyone has to start off somewhere, So.
Yeah. I think, for me, the best way to learn about coding is just actually doing it.
Yeah, for sure. Like sometimes when I'm watching like these video tutorials, I'm just like, you try to absorb as much as possible, but yeah, it's really not the same as trying to work through a problem.
Yeah.
And
then you can go back to the video and say, oh yeah, that's the solution, and then go back. But Google is the best tool for that, I think.
Stack Overflow.
Yeah, Stack Overflow. Yeah, that's where I live constantly.
Yeah.
I don't know if people do this, but those people usually have a list of things that they found a solution, and they just save it, because otherwise it just gets lost in your.
I definitely started doing that, actually. I have like a Google Doc of like links that I'm like, here are things that like I'll probably use a lot, but like I just fail to remember.
That's for the future you.
Yeah.
Yeah, that I try to do that, but I sometimes forget it, and then I'm just looking for that solution again for like a month, and because sometimes you find it and it's like great, and then you apply it, and then you're lost again.
Right. Yeah. I know this like might be like a little bit more intense, but I was just like, maybe I should like put some of these like solutions like on my website, because I can't control like what Stack Overflow decides to like archive or not or something.
Yeah.
Like that answer could disappear forever.
Exactly. You can also tattoo them, but that's more intense, I think.
I'm not sure if I have enough space on my body.
Or someone else. I try to do that just in a text. I have a text file, but yeah.
Oh, yeah. Okay.
But it's a good idea too. I don't know. There's actually like something called like software carpentry, where you have like some type of there's science behind doing coding, right? So because I'm a medical doctor. I come from medicine, and then I went into neuroscience and so forth. So you're not used to coding as much as people coming from from a coding background. So small things like to be clean, things like that are not obvious at the beginning, right? I don't know what's your background.
I did my undergrad in psychology, so before my PhD, I had zero coding experience.
Yeah, so I guess that's the most of us, right? That's what I find.
I guess it depends. I don't know. I feel like there's a lot of people with like who did their undergrad in like engineering or computer science, so they're a bit more prepared in that skill set.
True. I just find that sometimes like there's people that get really great solutions to problems, like great programs, and then you realize they're psychologists or they're some other background, and then just got into coding or something like that. That's or maybe that's why they stand out, but I find it interesting.
Yeah, I'm super glad that I ended up in a lab that like did all this kind of stuff. So.
So you want to advertise your lab?
Oh, well, okay. So I did my PhD with Pierre Valec in Montreal, and then I'm wrapping up my postdoc at NUS with Thomas Yeo. I'm actually moving like next week back to Canada. Really? Yeah.
You're in Singapore, right?
Yeah, right now I'm in Singapore.
So, and you're moving with Thomas? So right now, what are you doing? You're moving to Canada back?
Yeah, I'm moving back to Canada to actually start a job in industry. So
Oh, great.
might be
Congrats.
back.
That's a choice as well.
Mhm.
That's good. And did you find anyone who wanted to? I don't find anyone who wants to chat about their project. People are shy.
Maybe.
I mean, the idea will be to talk about your experience right now with the project and how it worked, if it didn't work, or maybe someone new wants to talk. I was hoping to have Pradeep here, but he's not around. He's always up for a chat. Or anyone else who wants to talk about their project, especially leads. I think it's important to talk to them.
Yeah, so during our intro today, we had a couple of the project leads like talk to us about what their experience was like so far during the info session, and like I think one of them even had like a small like slide presentation prepared about the progress and stuff. So yeah, it was like really good.
Yeah, I think that was the idea, but people are being shy now. Let me just ask in the hackathon. And if you want to leave at any point, just let me know. You're not bound. I'm the one bound here.
I don't want to leave you hanging. Like I understand being a host is like super weird because on Zoom, because like for you, like we're not seeing anybody else's like faces or whatever. And it's like the same thing on Zoom. Like no one has their videos on, so oftentimes you just feel like you're not talking to anyone.
Talking to the boy.
Yeah.
That's fine. At least it's back.
Kind of empty.
We're getting lonely. It's probably getting
Right. Yeah, I think people are just tired and starting at in half an hour.
Yeah.
I'm just going to ask on Mattermost if someone wants to talk about their projects.
Cool. And I just updated the document that we'll be sharing during the intro session. There's a few more links that Camille asked me to add.
Okay, good.
Oh, I really want bagels right now.
Speaking of bagels.
I really want a bagel.
You should have
Maybe
done.
I should consider now, Lisa.
Sorry?
Are you in Montreal right now?
No, so I'm actually in Brooklyn.
Oh,
so
okay.
I could go get a New York bagel right now.
Go to Bread Brothers Cafe. They had good bagels from.
I'm gonna look at Bread Brothers.
Yeah, I think it's Bread Brothers. Let me check my website where
Wait,
I blocked.
is that the one? Is that the one that makes like the rainbow bagel?
Yeah, I did have a rainbow bagel from there.
Okay.
I don't know if
never had a rainbow bagel.
It's an interesting experience. It's kind of like eating cake, but not.
I don't know if I like that.
Yeah, sure, but I mean, they had a very good everything bagel.
It's sweet or salty, savory.
I'm gonna guess sweet.
I don't know. The rainbow one.
It was like a little bit sweet. I don't know. It just the texture was like obviously maybe not obviously, but it was definitely like a bit different than like a normal bagel. So it was just like, oh, I kind of feel like this is like birthday cake, but in a bagel form. I don't know.
That's funny.
How I described it.
Weird.
Bread Brothers Bagel Cafe.
Have you found a new favorite breakfast item in Singapore?
Let's see, a breakfast item specifically. Okay, I actually don't usually eat breakfast because my stomach just needs time to, I don't know, get ready for food or something.
That's
like
fair.
I'm really hungry in the morning. So trying to think of something that's like specifically Singaporean and breakfast.
Well, I mean, I don't know if you have that in Singapore, but when I went to China, I had this amazing, cakes, savory cakes, but with pork. I don't know the name.
Oh,
But they
okay.
were amazing. In the morning, that was amazing. I remember that.
I'm really into Prada here, so it's
Prada.
like roti, but then they like put stuff like in the middle somehow. It's like a super thin crepe, and I don't know. Yeah, it's really good over here. I'm gonna miss that a lot. And you often have it with curry too.
I really miss like the hawker stands in Singapore.
Oh my gosh. Yes.
They're so good.
Outside, okay, because of the lockdown, they're gonna lift part of it the day after tomorrow. But yeah, like it's been such a weird experience, like not eating outside, like at a hawker.
Yeah.
It's just because it's like such a Singaporean pastime.
Right.
Yeah.
Yeah. Yeah. I remember when we went. Oh, right. You didn't go to OHBM in Singapore,
No,
right?
I
Because I
wasn't.
think you moved to Singapore right after.
Mhm.
Yeah. Yeah, I remember I was there and I was like, the hawker stands are just so cheap compared to like where OHBM itself was taking place. I mean, the prices weren't unreasonable, but it was just such a massive difference.
Yeah, I mean, you can get a whole bowl of noodles for $3. Like,
Yeah, that was my first meal in Singapore. I remember.
Yeah.
I had like laksa or something.
Eat noodles in the morning. Like, it's really not unusual to see
Yeah.
people eat
I will do that.
in the morning.
No problem.
I
mean,
noticed that in yeah. I was gonna say I went to Japan a few years ago and I noticed that as well, that there were, I mean, they're not hawker stands necessarily, and this was in Tokyo specifically, but I guess they still have like small little like restaurants with outdoor seating. And I would see people eating like whole bowls of like very hot savory soup in the morning, and I was like, that's interesting. I don't know. I mean, I know it's a very like Western, especially just like North American thing to have very sweet breakfasts. I think it's a lot less common in a lot of other parts of the world.
Yeah, yeah. Now that you mention it, yeah. Okay, so I mean, okay, one breakfast item that like I would like normally eat. Okay, I don't know. I eat this like whenever, but so there's this dish called congee. So imagine it's like porridge. Yeah, but it's like rice based. Yeah. So yeah, you see that here sometimes. And I mean, I grew up with it, right? Because it's part of Chinese culture. And everything some like my parents would or grandparents would make it. But I definitely am gonna miss like being able to like order it on demand, because that's not really something you can get as commonly in Canada and stuff.
You're moving to Montreal, right?
Yep.
Okay. And I remember Toronto has a great Chinatown, but I mean, that was like 15 years ago that I went to.
It's much bigger in Toronto than it is in Montreal. The Chinatown in Montreal, I mean, it's interesting because I guess there's technically like two. No, there's the one that's in Old Port, and then I feel like the Guy Concordia area has sort of become like the second Chinatown.
A little bit, yeah. I lived in the Guy Concordia area, and it was great actually. There were so many East Asian restaurants around, and like a couple, at least one grocery store, Asian grocery store.
Oh my god, there's so many.
Yeah.
On St. Catherine, yeah, I feel like there's one specific like Korean Japanese grocery store that's right next to Supermarché PA and like Adonis, and then there's quite a few like along that street.
Okay, and there's more.
Yeah.
Okay, remember.
Yeah. It's also interesting. I was like in that area like shortly before I moved away, and there's a lot of like Chinese specific delivery services in Montreal now that are specifically targeted. What? That are specifically meant for like I guess like Chinese international students. There's like 3 of them now.
Okay.
Yeah.
I should look into that. I mean, if it's written like in Chinese, I won't be able to.
It is, yeah.
Okay, well then it's definitely not targeted towards me, like because I can't read Chinese, but.
Yeah, well, I think specifically that area has a lot of like international students from China, so that's the sense I got. Yeah, I didn't expect the market to be like big enough to accommodate like 3 whole delivery services, but apparently they're all popular.
It's always nice to have that. Yeah, there's I do miss the pho in Montreal. There are some really good places there.
For what?
For Vietnamese. For pho.
Oh, for pho. Yeah. Mm-hmm.
Yeah. So there's a really good place that Malar took me to. It was quite amazing, especially at minus 20 degrees or something like that.
Oh yeah, pho is like really great for like, super cold.
Yeah.
Do you remember where?
Yeah, it's next to Chinatown. I don't remember the name, but I can surely find it. But it's just next to it's on the
Saint Laurent.
Yeah, I think it's the main road, and then just almost to the old town, and just in front of the Chinatown. There's this big place. I mean, there are several places, but that one is the one that he took me to.
Yeah.
It was really good, really, really good.
Nice.
We don't have that here in Mexico. We have other things, but Vietnamese is not very common. I mean, we do have it, but it's not great. It's not great.
Is there
the difference between Canadian pho and Mexican pho?
Sorry?
What's the difference between Canadian pho and Mexican pho? Like, why is it different?
Well, I haven't had it in Vietnam, of course, but I had it in Seattle and Canada, and I think this how do you call it? I forgot the name of that. The actual liquid. What's the name?
The broth.
Yeah, the broth has to be really good. Otherwise, it's not good, right? So I find that here in Mexico, they make a like a quick solution of that probably, and it doesn't taste. It's not rich.
Okay.
And transparent as it is in the other one. So I guess that's the secret. The broth.
Makes sense. Yeah.
Yeah.
But like a lot of things. Sorry.
Yeah, I was gonna say, I feel like it's probably the same thing with ramen, where like, I guess like excellent ramen, you make the broth over the course of like many hours. But I know that there's a bunch of just like the quick solutions where you basically just get like a very concentrated product that I guess you just like dissolve in hot water. Sure, it's not quite the same. I haven't actually tried those ever. I've only ever had, I guess, like ramen in a restaurant where I presume it is like they make the broth from scratch.
Yeah, the best I've had great ramen in Vancouver. I think that was a really amazing Japanese place there. But you can tell the difference after you eat the good thing. It's the same with all foods, I guess. Yeah, but there's a lot of quick solutions for ramen. But I haven't had I had it in China, which is but not ramen, but just regular noodles. But like to have great ramen, I think you need a lot of work. I've seen all the documentaries, so I know all about that.
I'm glad that we have again reverted to talking about food.
I love food.
This makes me happy.
Yeah, it does. It makes me happy too.
Yeah, which I guess because you said you've seen a lot of documentaries about food.
Yes.
Yeah.
Which I mean, I watch a lot of like food related like television and movies as well. So I'm curious, which ones are your favorites?
Angela or myself?
Both of you. You can go first.
Well, I mean, I mean, I like the Taco Chronicles. I think it's a very good, a small piece of Mexican food, just tacos, but it's a good summary, I would say. And I like the one. So there are a few ones from Japan about ramen that I like, but that's from YouTube. It's a guy. I won't advertise, but there's a guy that he's living there and he just goes to eat to all these amazing ramen places. But he also does like a small documentaries of how it's done, like how it is to work in one of those places, and I find that very interesting. I don't know. Yeah, Angela.
I can't think of any documentaries about food off the top of my head, but I really enjoy watching these like BuzzFeed tasty videos where there's this like one series where this like one woman, they give her this like trash food like Fruit Loops or like Twinkies or something, and her challenge is to make it fancy.
Gourmet Makes, like on Bon Appetit, Claire Savitz?
No. This woman called Rie McClenny, and he's a tasty producer at BuzzFeed. So they're like usually like 10-15 minute videos where she makes like, I don't know, these like incredibly complicated things out of like with this like trash ingredient.
Yeah. Okay, that is different. Yeah. What I'm thinking of is, I don't know if the two of you are familiar. On Bon Appetit, they have like a bunch of different series, like in the test kitchen. And one of them is run by this woman named Claire Savitz, who actually went to McGill for her master's, I found out recently. But she is a pastry chef by training. And so she's tasked with recreating like gourmet versions of very common snacks. So she's made like a gourmet Hot Pockets, a gourmet Snickers bar, like M&M's, Reese's Pieces, that sort of thing.
I was a fan.
So it's cool.
Until recently.
Oh God, I know. Last week's scandals. Oof. Yep.
Yeah.
Yeah, I know. That's why I initially, when I was like, should I even mention Bon Appetit right now? It's like, I love the content, but I don't love what's been happening the past 2 weeks.
Yeah.
Yeah.
Well, I mean, it happened, so it's
Yeah.
good that it's out. But yeah, I mean, I used to watch like quickly what they were doing, because they also did one Mexican snack called Takis.
Yeah. I love Takis.
Yeah.
I grew up eating those.
Oh, really? Do you get them
Well,
in New York?
In
or-
New York City, they sell them everywhere.
Yeah, of course. Mhm.
Yeah.
Yeah, you get everything there. Yeah,
Yeah.
the have you had them, Angela?
No, I don't think so.
They're really, I mean, they're really spicy, but also like in your face, bitter. I mean, it's not bitter. It's like I don't know. It's a special
It's like a
taste.
deep fried like corn like snack,
Okay.
basically.
Okay.
Yeah, but really strong flavor, and it's hot, really
Okay.
hot.
Sounds
So
good.
I think Asians like it. At least my friends do. The ones that eat a lot of chili.
Yeah. Okay. Yeah. Like I don't know if my spice tolerance has like increased or anything, but like the level of spice here is like, I don't know. I just feel like going back to Canada, everything is just gonna taste really bland or something. Okay, they give you, instead of like ketchup with your fries, they give you chili sauce here.
Oh, that's great. I love it.
That's
Yeah.
fine.
Yeah.
You know, we have this. We have the Mexican sushi, right? Which is basically sushi, but with Mexican tastes. And so we do like this horrible thing where you put the soy sauce and then they put chili in it, like raw chili, and then they just let it sit there. And I mean, it's good, but for us.
Yeah.
But yeah, having chili with everything, it's normal for us.
I remember like sushi burritos were a fad, like, I don't know, 10 years ago maybe? Were they a thing in Mexico too?
No. I mean,
Okay. I think they were just like an American like bastardization of both burritos and sushi.
Yeah, I mean, they could be, but like burritos here are not. So basically, the version you have in the US, is the US
Tex-Mex,
version, right?
yeah.
So
Yeah.
it's like huge. I mean, I've had it. It's just, I mean, it's too much for me. It's just a big thing, right? And here, when you see a burrito, it's different. It's smaller and has more. It has meat. Doesn't usually have that much other things like carbs. But
Yeah.
it depends on the state, of course. But yeah, it's not very normal to have a huge burrito somewhere. Like Chipotle, I don't know if it will last here that much.
Yeah. When I was in Mexico City, there was I don't remember where exactly this was, but I went to like a food market and they had a burrito that was like more like the Tex-Mex one, but they said it was an Argentinian style burrito.
Okay.
Where it also had like beans and rice and like all the things you would typically find in an American burrito.
Yeah. So yeah, I mean, Mexico, you find everything, right? Yeah. So, but that's not very common. I haven't eaten that since I've been to Boston to Chipotle, and it was really heavy. I
Yeah.
found.
It's funny.
Yeah, it's not very common. But yeah, I mean, burrito sushi. I don't know how would that work. I don't know.
I mean, it's basically just like a massive like hand rolls for sushi. It's really just that, but it's like much larger and is
cold?
just rolled like a burrito.
And cold.
Is it cold? I mean, the rice isn't cold. The rice is like normal, I guess, like sushi temperature rice, which is, I guess, like lukewarm. I don't know.
Yeah.
But I mean, the fish is still raw, so cold, I guess. Yeah.
Mm-hmm. We strangely have I say strangely because I live in a very small town compared to Mexico City, but we have a really big Korean population that is even near my area. So I'm very glad of that because we have all the ingredients and noodles, and so and we have the restaurants as well. So it's amazing, and it's really good. I would say they make Korean fried chicken as well.
I love that.
So
I'm beginning to.
Oh,
sorry. Go on.
No. Sorry. I have a bit of lag.
I was just gonna say that I mentioned this yesterday morning, but I really wish that we like had a way to actually get like delivery to every single hackathon participant. If we can get like food delivered to everybody, to like better mimic the brain hack experience of having lunch at the very least together. But
It will be a
Not sure
massive
if we can do that. Yeah.
order, multi-country.
I really love the Gather Town thing, though. You know, like
Yeah.
I like actually met one of my friends in there like yesterday and everything, and it was just like, oh wow, it's kind of really like being at OHBM together. You know?
Yeah.
You just don't. I mean, it would be great if you could modify your avatar a bit more.
Sure.
But yeah, because you don't see who's anyone until you get really close.
Yeah. That is true.
I haven't been to Gather Town that much. So we have 5 minutes for now, I think. Anything else we need to discuss before that?
I mean, like, if any project leads who are currently online want to give us like a quick update on like how their project is progressing, that would be great. Otherwise, yeah.
Seems that they are very shy.
Yeah.
So
I mean, according to the poll yesterday, people prefer to just like say things and ask things over Mattermost as opposed to, I guess, like via the.
Yeah.
I just saw Eric's message. I mean, you can just tell us what your experience has been like so far.
Yeah, let me invite him. He talked.
Okay.
So. Yeah, just talk about your experience. I mean, especially for newbies, I think it's important to know that, you know, not everyone knows what is going on sometimes.
Yeah.
And things can go slow.
Yeah, and we're always looking for feedback too.
Yeah.
Right.
Hi.
Good morning.
Morning.
Good morning again. How's everybody this morning?
Good.
Doing well.
Hungry, apparently.
That was what was that, Eduardo?
Hungry, apparently.
Oh, I'm just thirsty. So, yeah. So
I mean, the idea was for project leaders to just talk about their experience at the moment and in other hackathons, like for people that are new to this.
yeah. So I've attended. I think it was the OHBM hackathon in 2015, and I did the Stanford Center for Reproducible Neuroscience hackathon in 2017, I think it was, or 20. I lose track of years, honestly, but it's definitely different having a fully virtual conference, and I feel like it's a little more difficult to recruit people. And though GatherTown is very cool, it's also difficult with such a large space to run into conversations or overhear conversations that might otherwise attract you to other participants, you know, like hearing about different projects. But I don't know how you would be able to solve that problem in a fully virtual conference like this. So,
yeah.
Yeah,
I agree.
Yeah.
I agree. That might be a problem because you overhear things and then you look at people and just go there. I mean, I think also the young conferences were good for that, right? I don't know your experiences.
Yeah, unconferences are nice where you just sort of lightning talk, kind of get up and talk about what's going on. And to a small degree, I guess, if I were to talk about my project right now, I'd say we've only got maybe 3 or 4 people. Even Anders, the co-lead, kind of disappeared for a while, so I'm hoping he returns. But yeah, it's just a slower pace than before.
Yeah.
More focused in a way, but more sparse in being able to meet new people.
Right.
Yeah. Yeah.
I think
And I'm sure that's a challenge of this format too.
Yeah,
For
we're
sure.
not used to this as humans.
Yeah.
One of the project leads in APAC told me that it was kind of hard to get started because like there's so many different like links to different like meeting rooms and stuff. And I mean, I felt like we did, like you guys did an okay job in a good job in having this like one landing page with everything, but I guess it was still like overwhelming. And if you couldn't get to that one page, then it was just really cool.
Yeah.
Do you have any idea of how we could have like improved that?
It's a good question.
Yeah.
I'll think about it, but I don't have a real answer right now, I think.
Does
Okay.
Gathertown work? I mean,
GatherTown does work. I met like I think 2 or 3 new people yesterday, but that's a drastic change from older hackathons where
Yeah.
you know at social events, social lunches even, you run into many people.
oh,
So I guess maybe for now with the format that you have here, I would encourage people to try and overlap lunches with each other in GatherTown and gather in the same space, even if you don't know people during during social lunch times.
sorry,
Yeah.
I
But
have
again,
to change. Sorry, I have to change sessions. I think I'll
Yeah.
just go back and add you. Thanks, sir.
no problem. All right, thank you. See ya.
Thanks. Bye.
Cool. Oh, I think is he supposed to bring people into the next?
Okay, well, I guess waiting for if anyone has any feedback on yesterday's train track sessions and stuff, we're always happy to hear about how that went. So, you know, put your feelings in the chat. Okay, so for anyone who's just entering, I think we're just waiting for this session to switch over to the new Crowdcast welcome session, but it looks like the team's having a bit of technical issues. Okay, so for anyone who's just joined, I think we're just waiting for the crowdcast to change to the welcome session. And we're just waiting for the rest of the team. What just happened there? Okay, so for anyone who's just joining in to this crowdcast session, we're just waiting for this to switch over to the welcome session. I'm trying to get in touch with Lisa and Eduardo right now. Okay, so for anyone who's just joining, we're just waiting for the crowdcast session to switch over to the welcome session. Just trying to get in touch with Lisa and Eduardo, and I'll try to keep you updated.
keeping up with my existence. But you know, I'm still kind of hanging around in the background. Happy to help. Hey, Michael Hanke. I guess there's lots of people buzzing around.
Yeah.
Wait a minute, Michael, isn't Michael supposed to be in the European? You're invading the Americas. What's going on here? Why is he part of America?
I'm in Singapore right now.
I thought he was banned from America. So aren't we supposed to get moved over?
I have no idea. That's what I thought too. But if we're not the only ones, it's like how many people are still here right now?
I don't know, but that's great. It feels like we can control their attention. We can say whatever we want. Wah.
I was in like the coffee session and stuff, and Lisa and I and Eduardo, like we straight up like talked about food the entire time.
You talked about which?
Food, like ramen.
Food. Right. Okay, well that's a good topic. I like to eat. We could also talk about like booze or, you know, other stuff.
Are bars open yet in Montreal?
You would think I would know this. No, I don't know. I'm not sure. I don't think so.
Okay. Okay, so I guess you haven't really been out.
No, sadly, my party image is getting tainted. And, you know, I haven't even been running or anything either. It's like, it's pretty bad.
I mean, it's hard. It's such a weird situation.
Yeah, that's true. I mean, there's a lot of things that are very disruptive right now. So
yeah,
it affects different people differently too, I think.
Yeah, definitely. I'm definitely well, so Singapore's finally kind of lifting up some restrictions and stuff. So for the past like more than 2 months now, it was actually like straight up illegal to meet up with anyone who didn't live with you, even if you were like social physically distancing, like even if you were like a meter apart, you couldn't like take a walk together or anything. So I actually haven't seen anybody that I've known in person for over 2 months, and it's super weird.
Oh yeah, geez.
Yeah.
And yeah, they're pretty strict with the laws in Singapore too. So
yeah,
but
I'll just like, if you're foreign, you can get deported, and I'm like, I guess I don't want to do that. So
yeah. And like the implementation of the laws are different. Like here, there's rules and stuff, but you know, probably you wouldn't get deported if you were like 1.8 meters beside someone versus 2 or whatever.
I mean, like some of these things are like super hard to enforce, but it's just like if you're the one who gets caught, you can get in like a lot of shit.
Yeah, I know. I almost got arrested in Singapore myself.
Why? What did you do?
Illegal swimming.
Illegal swimming? Where were you swimming?
I was in Sentosa Beach, but I was like, I didn't understand, so I swam to the other end where there's these rocks, and I just got up and started climbing on them to get out of the water. Next thing you know, alarms are going off, and people start running up to me and start yelling at me about stuff. Like they're like, "Do you think that was safe?" And I was like, "Yeah, that was very safe in my head," but I didn't say that, of course. I was like, "No, maybe that was not the best." But I felt like I was about to go to jail.
Right. Yeah.
So that kind of stuff can happen. Anyway, I don't mind almost getting arrested if it's for the right reason.
But you could get caned here, depending on like what.
Hey, some people like that.
Okay.
Yeah, no, that's caning is like, I don't know where exactly they implement that, like for what issues, but yeah, that could, that's definitely, like, I remember there was that teenager a few, like 20 years ago who was vandalizing stuff and he got caned like 7 times.
Damn. Apparently, only men get caned here.
I
I don't know.
Oh yeah.
Fun fact.
Okay. Well, anyway, I guess maybe people can hear us because Dave is,
Yeah, I think so. This
is
is
laughing at some of the stuff I'm saying, or
Yeah.
embarrassed maybe. You're embarrassed of me, Dave?
I think
Jeez.
maybe if we refresh, then it takes us to train track or something. Like I had this issue a few minutes ago in the switch from the like morning social to the introduction thing.
You know, I don't mind telling stories to the people that are held hostage on this on this broadcast. I'll tell you guys all about all the other times I almost got arrested, you know? I'm fine with that. So we could go down that road, or we could do the same thing and maybe log out and go back to where
It's up
everybody
to
else.
you. I mean, I don't have anything else to do, so.
I almost got busted in the States too. Try crossing that border. Woo.
Wait, you were trying to cross a border without?
Oh, when you cross the American border, they always ask you so many, I don't know, I think questions that are not needed. But
Okay, I see. Okay.
yeah. At least I'm not Michael Hanke. At least I can get in. But so when do you come back exactly? What's the story?
So I have to quarantine for 2 weeks when I come back. So I'm gonna do that at my parents' house in Ottawa. And I don't know, I'm not like super sure actually when I'm actually gonna move to Montreal, just because I don't really want to move there if I'm just gonna be remote working still. Like I really think in office, like I don't know, I'm just kind of sick of working from home. So I feel like I might as well just like okay, I'm sick of working from home and living by myself. So I feel like if I have to work from home, then I'd rather just do it at my parents, because then at least I can talk to them and like see them every day or something, you know.
But are you going back to UDM, or what's your story exactly?
Oh, no, actually. So do you remember Christian from Pierre's Lab? He's super tall.
Yeah, for sure.
Yeah. So he founded a startup and he asked me to join. So we're driving the dream team.
Awesome. So, and no more academia for the time being, at least.
Yeah, this might be my last brain hack.
Oh, wow. Okay. And that's in Montreal, this startup, right?
Yeah.
Okay. Cool. What is your exact startup?
So it's about making tools to help refine patient selection in clinical trials. So we're pairing biomedical data with machine learning to kind of like determine who is most at high risk of developing a certain disease, or who would be a likely responder to it, a certain treatment.
That definitely seems like a growth industry. So makes a lot of sense. You know what else makes a lot of sense? The Canadian Open Neuroscience Platform.
Oh yeah, are you gonna try to recruit me?
Well, I mean, Tristan and I are doing a demo at 2:00. So that could be a good way to store some of your data, machine learning or otherwise, you know. So,
Okay.
so you can join at 2 and see what that's all about. We'll go through it live, and you know, it's always, because anything machine learning, deep learning, you need to have data, right? I mean, you need to help to have open data, helps to have data that people can access. That's like a big part of this. So there's still a like industry academic potential for collaboration there always, you know. Anyway, we should probably go, or try to, I don't know, it's not taking us anywhere. So maybe we should try to log out, log back in, and find where.
Maybe you just refresh.
Yeah, or refresh. Exactly. Okay, well, nice chit chatting.
Yeah.
À tantôt.
See you.
saying that no empty on file, as if it's the only file that may not exist. And then after, if there are some files, it will loop over them. And then do a complicated check. If these files are compressed, it is going to decompress them. For if it's empty on, then it's going to decompress it and load untouched that empty on file into the empty underscore on variable. It's going to repeat the same thing for empty off and FA if they are zipped. And if directory includes some nifty files but they are not compressed, then it's just going to go ahead, find them and read them into now different types of now it's going to read it into struct. So even at the first conditional code block we have some inconsistencies. Anyway, we will take some notes down and leave. So we will say that this section is to check if files are compressed or not, or if they are nifty with specific names. Moving on with the inspection, we see that empty_on.prefix field is assigned with some metadata from the struct that is created by the load_nifty function. And this is the point where it actually displayed the origin from Q of Z, X, Y, and Z. It gets the origin information into the struct later on, and then it's also reading the dimensions from the nifty metadata. And then here we see an operation. Oh, we have a comment here. Thank you, Jim. It says that flip dimensions twice, but why? We don't know. We are yet to understand it. So yeah, it casts the data into double format. It is important if you are dealing with quantitative images especially. And then first flips the second dimension and then flips the first dimension and gets the size. And wait, it's doing the exact same thing it did for the empty on for empty off. So let's put this duplication notice to make our life easier. So I said duplication start, it read the metadata, double flip, and then put this mysterious empty off direction hard-coded value, and then we see that the same thing is happening for again FA, Philips FA, and here it is. Okay, I changed my screen recording tool. Now I'm using Loom and hope that this is going to be better. Anyway, so here we see a new struct definition, plot, and then into this plot structure there is a new field assignment for slice, which is set to 30 using function round. There is no meaning to use round as 30 is already round, so there was round here. Why? Probably there was a variable that Jim got rid of and it was a leftover function. Then it defines a new field with capital Z, which simply defines once matrix multiplied by 30 to create an in-plane slice on which we are going to display our image, and also created a mesh grid for that. So this is simply create AGK domain to plot. And then we see that it fetches metadata from empty on image, origin, spacing, and it also initializes new fields, this time lowercase x, y, and z, which is probably going to store transformed indexes. And then along those in-plane axes, it performs a for loop and calls this change PTS courses. So obviously this function is responsible for transforming points from IGK to XYZ when you pass this magic argument. So let's say this is for IGK to XYZ, and it is assigning values to the fields that were described here. And yeah, we keep seeing this plot dot direction, this identity matrix many times. So this is hard coded. So I will take a note. There is a hard coded identity matrix throughout the script. We'll find it out. And then it takes these intensity from empty on, calls this map-to-gray function to map grayscale values, and then finally calls figure and uses surf, because if you'd like to display your image in real-world coordinates in 3D, you need to use surface plot. So use surface plot to display image in world coordinates, and then hold on, which means that expect something to be displayed on it. Now we are reading yet another file, which is .trk read fibers, and again it gets the list of all the fibers with trk extension. This can be trk or trk.gz, and if empty it throws an error, blah blah blah. It's again trying to understand if it's compressed. Should I decompress it or should I read it directly? Oh god, it's too many unnecessary file checks. And then finally, when it manages to read that file, it says that number to string length of tracks has been loaded. So this is the specific line of code that told us 500 tracks has been loaded, which also means that the coordinates of the streamlines are stored in this trc key as stores streamline coordinates. And then here we are reading some other file, which is, yeah, you see what we had in the folder was transform.txt, but obviously Jim had the same file in transform.mat format, so we don't have transform anymore. Read these files. Now we see that there are some operations happening on the affine transformation matrix. It takes the fourth column, the first 3 rows of the fourth column, which is the translational component of an affine transformation matrix, and scales it with the diagonals of the orientation matrix. So it is kind of, yeah, update translational components of the affine matrix. Then set scale factor to identity. So yeah, it is just using the information within matrix to change the spatial location of the fibers in world coordinates, but it doesn't want to scale it up or down. It is trying to keep the size of the tracks the same, and then copies those tracks into another variable, which is named fa. And then here, yeah, it is doing some kind of transformation to the fibers. So apply modified transformation to the original fibers, and here tracks fa is transformed differently. Apply transformation to the original fibers again with different transformation. We probably won't need this at all, because our main purpose is to do interpolation using MTR values, not this domain. And then it finally plots fibers, and then another duplication to do the same thing on FA image. I'll skip that part. And here we calculate MTR images. By the way, I inserted these comments. It is a super simple calculation. Here, this is how you get your MTR image. MT on minus MT off, absolute value of it divided by MT off gives you the magnetization transfer contrast that you need to understand the myelin content. Now, once you have this image, you need to interpolate MTR values on streamlines, and you achieve this by calling this inverse distance weighted 3D interpolation function with tracts and MTR. And then you finally loop over every single fiber and every single node again to apply this interpolation and save new scalars as the fourth column of the tracts matrix. Normally it was it had 3 columns for X, Y, and Z, and once we calculate new scalars, we are just going to write them into fourth column so that it's going to be recognized as a scalar. And this time when we are plotting is when we are calling the TRQ plot function, if you may notice, we pass header, tracts, 2 empty arguments, whatever they are, and scalar first. So this means that use the first scalar that is written into the tract matrix and display the new fibers. So this is how we were getting the images saved in, let me find them quickly, Brainhack, GMMTR, subject to, so yeah, these images. These are streamlines with MTR values written. Please don't let this complexity intimidate you, because I wrote this code myself 2 days ago, and when I was trying to refactor it, even I was not able to understand what I did at some parts of the code. But this was kind of exactly the point. How can I take a 330 lines long code and create something modular, something useful out of it? And to do that, sometimes you may need to read the same code, the whole thing, a few times. But now I have a better feeling of its main components, and I think I'm ready to go ahead and create an empty repo to take some notes about what kind of refactoring I'm going to do. So I'm creating a new folder called refactor gym, and now I'm going to create an empty Git repository by typing git init. So now there is a version control in this folder. Now I'd like to add some files and give this folder a structure, and I'll start by putting some empty files. The first one is going to be refactor.md, the file that I'm going to take notes about what kind of refactoring I'm going to do, and I'm going to put this at the base of the repo. And then I'm also, of course, going to create my readme.md file. Another good practice is to keep a change log. I would like to keep my scripts in a folder called src, which stands for source. So I also create that folder, make their src. Another folder to keep external files such as load nifty, or those files responsible for reading and plotting tracts. So any code that you'd like to use but you didn't write. And these are probably living in another GitHub repositories. So I'm also going to show you how to add those modules as sub-modules, which is super useful to make your code base easier to maintain. Now we are back to our MATLAB editor because we are going to write our first function which is going to be getData.m. So let's save the script under source directory, getData.m. As you noticed, I follow the camel case because this is what is suggested by the style guidelines if you're writing a MATLAB code. The same applies for variable names. So the first thing that I'm going to do is to copy paste a header comment template, which is here. This is, let's write a super brief description. This script is used to read necessary data and header to perform MTR analysis. We are going to describe the syntax here, and I like this function to give me two outputs. The first one is data and the other one is header, and as inputs this is going to take empty on image, empty off image, some fibers, and we are also going to add this var argument, which means that variable input arguments that we are going to use in parsing them with input parser. And for inputs, let's type empty on, this is nifty file. I'm just gonna put super brief descriptions. Empty of, which is again a nifty file, and this third one is the fibers. This is going to be a trk file, and it's going to give me two outputs. Data, which is going to be a struct containing empty on, empty off, and fibers. Header is going to be a struct again containing metadata that belongs to empty on, empty off, and fibers. Made a lot of typos. And these parameters include, we'll come to that once we are done with this M file. It says other M files required none and everything. We can just simply skip these parts right now. If you also have some other functions you want people to see, you can add them here, see also. And you may want to put your email address here so that people can reach out to you if they have any questions regarding your code. And this is June 2020. And yeah, now we can start writing our function. As I did above, I'll quickly define it by function data header, which is going to give a get data empty on, empty off, fibers, and variable input arguments. All right, so let's first thing first, I'd like to create an input parser so that I can make sure that the variables passed by users are going to be valid, and I have an organized way to access everything. In MATLAB, you achieve this by first constructing an object that belongs to the class input parser, and you achieve this doing by simply p equals input parser. That's it. And as I write my code, I'm going to insert lots of comments to make it easier for people who are going to read this in the future. So I'll say create input parser object, and I also like putting this kind of separators to make following code easier. And now I'm going to set my input conditions, and I'm going to allow only decompressed Nifty files for the sake of this example. So I'll say only decompressed Nifty inputs, which means this. And now I'm going to write some anonymous functions to create validation rules. So let me show you how to write anonymous functions. So for Nifty validation, let's call that variable, well, ni, and this equals, you put this at x, and you use this x as a proxy for the checks that are going to be performed in another functions. I think it's going to become more clear as I write it. So the first condition is that I want this mt on to exist as a file. So I put x and put file here. And I also want it to be a Nifty file. So I'm just going to check the last 3 letters in the file name to see if it's NII. And to add it as another condition, I'm just going to add this strict comparison. I'll take x and from and -2 to and, which is the last 3 letters, and see if it is ni. So I created a condition as an anonymous function to validate my Nifty inputs. I'm going to do the same for TRK files. So now I'm going to say, well, only the compressed TRK files. And here I'm going to call this valid TRK. I'm just trying to maintain consistent variable names throughout the script. And in this case, I want this to be a file again, along with the condition of having the extension TRK. Great, so this is super cool. We can create customized input conditions without using any if statements that makes things a bit more complicated. And this input parser can be used in Octave also, which is super nice. Now we are going to tell input parser which inputs are going to be required. And required arguments are positional. So if you see variable names explicitly declared in the function prototype, it means that these are going to be required inputs. And if you have, by a rule of thumb, if you have more than 3 variables, you may want to add them as a struct, so that one struct can contain multiple fields that can be processed by your script. Otherwise, your function prototype gets really long for too many required arguments. So now let's add required parameters and check for types. And to do that, we will use add_required function, and we are going to pass our input parser as the first argument. The second one, I'm going to put empty on here, as I described in the function prototype. Empty on was the first variable. And then the third argument is going to define which checks are going to be performed on this input file, and I'm going to put valid ni. And that's it. And I'm going to do the same thing for empty off, and this is going to be subjected to the same Nifty validation rules with as empty on image did. And finally, required fibers, and this is going to be valid TRK. Once I'm done with required parameters, I'm going to add some optional parameters, and in this case I'd like to pass this hard-coded identity matrix that was present throughout the script. So apparently I need that information somewhere in the following functions. So I'm going to pass it as an optional argument. And to do that, I'm going to use a function called @parameter. So I'm just quickly type a comment at optional inputs. So there is also another function called @optional, but if you use this, it is going to break compatibility with Octave. So instead of this, just use @parameter and and I'm going to name it orientation. And the cool thing is that I can set a default value. So if user do not pass a value with as orientation, I'm going to have an identity matrix here. And my validation rule is going to be his matrix. So if you have just one condition to validate your input, you can pass it right away as an argument inside of this @parameter function. It makes your life easier. Now finally, we are going to parse these input. Parse parameters. And to do that, we are going to call a function parse. We're going to pass our object. And now we are going to use these as they are one by one. So empty on, empty off, and fibers. And we also have some variable input arguments. We are going to pass it as a vector. So it's done like this because it's a list of cells. If you want to vectorize it, you gotta use curly braces. So here we go. We just wrote an input parser that would take, I don't know, at least 100 lines of code if we were to use if, else, and check for different types of conditions. This is super concise, and once you get used to it, it is a really good addition. And you may also ask the question, should I write an input parser for every type of function? The answer is no. So if your function is going to be consumed within a for loop, this checks can create an unnecessary computational overhead, and you may want to avoid it. So if you need performance, you shouldn't add these input parsers. So it is meant for the functions that are going to be used by human, not by other software pieces. Let's see this input parser in action. And to do that, first I need to add everything in my current directory to the search path. And to do that, I'm going to simply do add path, and to include subfolder, you can add this generate path. And here I'm going to pass pwd, which means the current directory, and everything in this directory is going to be added to the search path. And then to test this, I can go and check a data folder. So let's navigate to this directory, and let's copy this so that we remember the function prototype nicely. First time I'm trying to run this, it's going to throw me an error because I didn't complete the whole function, and I am asking this function to return two variables called data and header. So, but I'm going to pass correct input names in it, and here we have corpus callosum 500.trkey. So when I call it, it's going to say argument data, and maybe others are not assigned during the call to get data. But I'd like to see if my parser works. To do that, I'm going to set a breakpoint in my code by just simply clicking here. You see that red dot means that your code is going to start executing line by line, and it's going to stop here, and all the variables in the workspace of this function is going to be accessible through your command window. So let's add one more breakpoint here to show you how it works. So now when I call that function once again, and here you can see this little green arrow, it says that it is waiting for my next instruction at this line. And when I click step, it is going to go step by step. And when I click continue, it's going to run everything until the next breakpoint, which is the line where we call the parse function. So now here, if you see this K before these symbols, it means that you are in debug mode. And when I copy paste this parse and execute that line, now if everything went right, I should be able to see my inputs in p.results. For example, for empty on, it gives me empty on.me. For empty off or dot fibers, you can see the fiber file name. Or you remember we also passed an optional argument, orientation, but I didn't do any I didn't add any input arguments for that, so that it's just going to show me the default variable. To quit from debug mode, you can simply type db quit here, or in this window there is quit debugging button that appears. So let's do one more call to this function and see how can we pass an optional argument to this function. And the name of that argument is going to be orientation. So I will just add orientation and put some, I don't know, random, it gotta be a matrix, so this should work. So here we are again, hit this breakpoint and it parsed, and when we see our results.orientation, now we will see the custom metrics that we passed instead of the default value. Let's quit from the debug mode and go back to the working directory, just so that we know we are at that point. Okay. So now once I have a good way of receiving my inputs, now I gotta start initializing correct objects to store them. And to do that, I'm going to use structs, because we have both data, different types of data, different types of metadata, and I like to keep them organized using different fields in two structs. One of them is going to be data, and the second one is gonna be header. And while initializing structs, I could have done this: data equals struct, but this won't give any clue to people what I'm going to put into this struct. So instead of following that convention, I'm going to explicitly specify which field names are going to be present in my struct. So struct, and the first one is going to be empty on. I don't know what how big that matrix is gonna be, so that I'm just going to leave this part empty. If you are sure about the type of data that's going to be loaded in, you can also specify empty matrices or vectors to make your code more performant. The second one is going to be empty of, going to receive some image, and we're also going to receive fibers, which is going to be empty again. So let's say initialize struct for data. Now we initialized our outputs as structs that we know going to have the fields of empty on, empty off, and fibers. Now I'd like to add some sub-functions to this function that only pertains to this get data functionality. First of them is going to be get nifty header, and the second one is going to be get flip nifty image, because we are not just going to read the image, but we like to flip it. The reason is that when you read nifty data into MATLAB, they have different descriptions of origins. One of them is on the upper left and the other one is on the lower left corner. So you need to flip images to see them in the correct orientation. So I'll just copy paste these functions for get nifty header. I'll just copy paste it. It's simply getting a nifty file and giving us a header output, and it is using load nifty header function. and it is assigning more useful names to the other fields. So it takes offset XYZ, for example, and puts it into header out.origin. And then the second function that I'd like to add here is to flip nifty image with some descriptions in it as well. So it says due to differences in MATLAB versus nifty orientation, blah blah. It's just image double load nifty data and then flip these dimensions as it was done in the GIMS code. All right. Now I'm going to use these functions to assign values to the variables that I just initiated. So for empty on, the header is going to be header dot empty on equals get nifty header, and I'm going to get the file name from my parser, which is p.results.empty on. Then I'm gonna do the same thing for empty off, because empty off is also a nifty file. And now I'm also going to do something similar to read my data, but this time it's going to be data.empty on equals get what's the name of the function, get flipny image, again p.results.empty on. I'm going to copy paste the same thing for empty off. So as you can see, I'm started to showing a pattern when I'm doing same thing multiple times and just changing variable names. Whenever you feel like you're repeating something, you're duplicating function calls, but the only thing that is changing variable names, and especially if they are changing in a systematic way, as we are doing here, you should probably write a simple for loop to handle this kind of input case, right? So obviously, the determinant factor here is that if my inputs are nifty, I can loop through this p.results.empty on field and see if I can call them. But how am I going to know these are going to be associated with nifty files? I'm just going to simply create a list called nifty list, and it's going to be a list of cells, and the first one is going to be empty on, the second one is going to be empty off. Oops. Right? And then I'm going to iterate these items and look for it in the objects of p.results. So I'm going to say for I, this is how you should define your iterators, by the way. The most common one you will see is I, which is definitely not understandable. Or if you use I, MATLAB is using the same notation for complex numbers, so you may want to avoid it. So I'm just going to simply say I is going to start from 1, and it's going to go to the length of my nifty list. As you can see, there is a consistency between the name of the iterator and the list that it's going to iterate over. And I'm going to get the current name. I just say name is going to be nifty list. You gotta use curly braces again to access the index stored in a cell, and it's going to be take my iterator. Now I'm going to simply check if this is not empty, if p dot results. So now I'm going to check if p dot results contain something that belongs to the nifty list. But how am I going to take that one string and use it as dynamically accessing to a field in a struct? To do that in MATLAB, you can simply use parentheses, and then when you type name here, it will do that check for you. So this is really useful. I use it a lot. If you know these tricks, you are not going to feel the urge to use eval or some other kind of circumventing functions to do these operations. So now I set my condition. So then if this happens, I'm just going to say that, okay, now I know that this is a Nifty file, and I have some simple rules to read Nifty files. So I'm just going to read header dot name is going to be equal to get Nifty header, in this case p dot results dot name, right? And remember that I also like to inject some other metadata, which was called orientation, and this is a great place to do that because I just want to access them in Nifty files. So I'm just going to say header dot name dot orientation. Now I'm adding a new subfield to that, and it's going to be p dot results dot orientation. I hope this is not boring. I'm just repeating things on hoping that they are going to become more clear. And finally, I also like to store the file name that is passed to the input, which is useful, and that's going to be the name itself. And finally, I'm going to read the data dot name, oops, not like this, like this, data dot name is going to be equal get flip nifty image p dot results dot name. Yeah, that's it. Now we can delete these lines and we don't have any repetition. And another cool thing is that this is scalable. For example, in future, I'd like to use the same function, but I will have other Nifty files required. Let's say FA. I just need to do this, nothing more. If I add FA here and to my function prototype, my function is just going to simply read it without any other additions. So this is also good for modularity. And the last thing that we need to do is to read inputs for the trucks, fibers, and it has just one simple function, which is trkey read. And here in trkey fibers, how did we define that name? As we called that p dot results dot fibers, and here header dot fibers and data dot fibers. So that's it. We wrote a function finally with header input parser by initializing our outputs and then reading our Nifty files. Read Nifty. I'm going to add more comments to these codes later on, so when you're reading them from a repo, I hope that this is going to be more clear. And on purpose, I'm going to leave many of these functions without any header information or any comments, and kindly ask you to make pull requests to my repository to create a more understandable code base so that we can at least some interactivity. Yeah, that's it. We have our first function, get data. So I took advantage of recording this online and edit all other functions that I'd like to create during my refactoring process under the source directory. Because otherwise it would be really boring to show you what to do specifically in each of them. So first, let's go back to the getData.m and remember that there were some functions such as this low Nifty header or functions to read our fibers that were added externally to Jim's code. So what I'd like to do is to find those repos and add them as submodules to our repo. And I collected all those relevant links. Remember that we had an external directory here. This is where we are going to host all those functions as submodules. And to add a submodule, I just simply say git submodule add, and I will now copy paste the repository URL for check my code, and then I am going to say where I am going to put this function in my repository. In this case, I want to place this under external folder, and I'll call the name of that folder check my code, and I pass recursive, oops, not this one, and use shallow submodules so that I don't need every branch and every commit. I just want to get the latest one commit. So that now it's cloning it into the external check my code. And I also would like to add Nifty library. So same thing, git submodule add this external slash MATLAB Octave Nifty, I will call this, and recursive shallow submodules. And there is one more library. This is for reading and writing our fibers. Again, git submodule add this to external, I don't know, let's call it trkey tools, recursive shallow submodule. Now it's fetching the repo. Cool. Let's see now what we have in our external directory. As you can see, we have MATLAB Octave Nifty, check my code with a typo as usual, and track tools. And everything we want is available here. But the thing is, let's see which submodules we have, and it is git submodule helper list. Yes. So it says that we have 3 submodules added with these specific commit hashes to our repository. And when we push it, it is really not going to push them to GitHub as files, but it's just going to push this information so that GitHub is going to know that these are submodules, and it's going to point to other repositories. So when you're cloning a repo that has submodules, when you do git clone URL, you will only get the codes that belong to that repo. If you'd like to clone repository with submodules, you need to do git clone URL -- recursive. Just additional information. So now I'm going back to my editor now that I have my dependencies. And external, I need to add these to my search path. So again, add path. Cool. Now I'm going to try my get data function and see what it gives. And to do that, I need to navigate to a directory that contains some data. I have some data here, yes. And let's see. Empty on me and empty off, and for disclosure 500.trkey. All right. So now we called our function, and we have 2 variables. One of them is data, and the second one is, let's see what we have in data dot. We see fibers empty on and off. Let's see what do we have in data empty on, and I don't know. Cool. We have a brain image. So yeah, and also in the header information, we again have the exact same field name. So there is this consistency that's going to make our life much easier. Header.empty on, for example, has fields name, orientation, origin, size, and spacing. If you remember, we injected these metadata while loading the file names. And now when we get origin, yeah, this origin for this data was 000. This is nice. So I want to show you some other things regarding functions before writing tests. And there is something I added in this transform fibers function. Before in Jim's repo, we had this nested for loops to iterate over every in this fibers variable. So maybe I should show you this. Fibers is going to be data.fibers, and when we check the type of the fibers, it's a struct array. And to access elements of a struct array, let's say this trk1 equals, you need to call it in this fashion. So we know that truck1 is a fiber that has 193 nodes with these coordinates. So in this part of the code, I am looping through the length of fibers, and in each fiber I'm also looping through nodes. And one bad thing about looping too much is that your code on Octave is going to become much more slower. This is because of two reasons. One of them is that to do vector and matrix operations, by default MATLAB is using something called Intel's math kernel library, whereas Octave is using something open source, so it's a bit slower than what Intel provides. The second important thing is that MATLAB has a better architecture to understand loop logics in your code so that it can execute them faster. Anyway, these are probably too much detail. So instead of writing a nested loop, I used array_fun. So the function of this array_fun is to execute a function on each element of an array. In this case, our array is a struct array. And as you can see here, we have that anonymous function again. So it tells that, okay, perform this action on X, which is fibers, and assign its output to this variable called tmp. And here I defined another small function to do that transformation. You can write the function between these parentheses, but if it's something a bit longer, you should better write it here. Now I will take a closer look at this array_fun at the line 45. If you remember in the presentation, I told you that there are fun functions and there was a series of blog posts about it. So I think this is a good place to talk about them a bit. Before we refactor the code, this operation, that was a nested for loop to transform fibers, is now performed by a single line of code, which is called array_fun. So first, let's see how it's going to operate by placing a breakpoint at line 53 and calling the necessary functions. First, I will read the data and the affine transformation that I need to call this function, transform fibers, and then I will call the function itself by passing fibers, origin information, and the affine transform to it. And we see that the function executed in 0.01 seconds, which is pretty fast. And how long would it take if we were to execute this function in an old fashion? Let's see it. So yeah, the new one tenfolded the old one in terms of speed. But this may not be always the case with array function. Probably there was something worse going on in the code that we refactored, so that we see that array function improved the performance a lot. But this may not be the generic case all the time. Anyway, I'm going to add a lot of tips and tricks about how to improve the performance of your MATLAB code in this transformfibers.m. You can find them in the repository, and that content is going to include things like vectorization. The most important thing is pre-allocation, implicit expansion, and fun functions. So anyway, what is this array fun doing in here? We see that it begins with an anonymous function description again. It says that, okay, I'm going to run this function on X as a proxy of fibers variable. And then we also see uniform output false. So you set this to false if the anonymous function is going to return outputs that are not equal in size, so that the array fun is going to store them as a cell array. But if you set this to true, then you assume that every single return from that function is going to be equal in size. And here, our anonymous function is calling a subfunction called TFM, which is described here. I did this just to keep this line shorter. And remember that there is always a trade-off between the speed and the readability of your code. Sometimes while you're trying to optimize performance too much, you may sacrifice lots of clarity. So you may also want to avoid that. It's really a matter of trying to find the fine tuning. Anyway, this array fun steps into this TFM, and this is where I'd like to talk about this implicit expansion. So let's see it in action. I'll call that, not this one. Yeah, I will quick from this debug mode first. And all right. Now we are in this particular line where implicit expansion happens. So when we'll take a look at this code, single line of code, it does matrix times transform. So our matrix in here is 110 by 3, and normally you can multiply this by a 3 by 3 matrix. So that's normally happens. Let's see what it gives. Let's see, it's equals to C. And yeah, variable C is going to be again 110 by 3. But then here's the weird thing. Size of this variable is 1 by 3, and somehow we can add C with this 1 by 3 variable, and we get a result. Let's see, output equals C plus transform. As you can see, it gave us another variable which is 110 by 3. So MATLAB understood that we are trying to expand the 1 by 3 vector along this singleton dimension to match the size of this 110 by 3 matrix. Maybe I can give you a simpler example. If A were equal to 1, 1, 2, 3, 4, 5, 6, and B was something like 10, 10, 10, and I would be able to do this A plus B, which would give me this. This is also the equivalent of VSX fun and A plus AB. So this function is available for MATLAB versions older than R2016B. But if I try to do this A plus B in MATLAB R2015A, let's say, it's going to break. The same applies for Octave for versions 3.6.0.
that will be time well spent. In terms of the presentation, I'm used to giving sort of conversational interactive talks. I'm not an expert in kind of pre-recording a talk like this, so I apologize for that. I'm going to keep it kind of informal. So like I said, this talk is about BIDS and BIDS apps called The Benefits of BIDS, Data Standardization and Automated Processing for Neuroimaging Research. Okay, hello everyone. My name's Sam. Welcome to the OHBM Brainhack 2020. This is a train track session on BIDS and BIDS apps. I'll start by saying unequivocally that Black Lives Matter, and that one of the most important things we can be doing right now is figuring out how to act in solidarity with and provide material support to the Black communities and anti-fascists that are currently struggling against white supremacy and state-sanctioned violence from the police. So if you spend the next hour doing that instead of listening to this talk, that will be time well spent. In terms of the presentation, I'm used to giving sort of conversational interactive talks. I'm not an expert in kind of pre-recording a talk like this, So I apologize for that. I'm going to keep it kind of informal. So like I said, this talk is about BIDS and BIDS apps, called The Benefits of BIDS, Data Standardization and Automated Processing for Neuroimaging Research. Now, I am not the sort of creator of BIDS. I'm not even really a contributor to BIDS. I am just sort of acting as a cheerleader here because I think that it is a hugely important step forward for our field, and we should all kind of work to increase the adoption of this. So with that said, I will first of all thank the many contributors to BIDS. BIDS is a very community-driven project. And you'll see here in many places in my slides, things that are this color blue like this are actually clickable links. So if you click here, this is going to bring up the actual contributors list from the BID specification GitHub repo. As you can see, many people here, I don't have time to go through all of these people, but it's a lot of people from Russ Boldrak's lab, Chris Gordolewski, Stefan Appelhoff, Franklin Feingold, Tion Brooks, Chris Markovich, and so forth. What is BIDS? BIDS is the brain imaging data structure. So BIDS is a standard for organizing neuroimaging data that facilitates reuse and automated processing. And I'm going to unpack these terms, reuse and automated processing, as we go here. The BIDS standard specifies machine-readable directory structures, file names, file formats, and metadata. Machine-readable is the kind of is the keyword here, and this rich metadata is going to be very important for our purposes later on. BIDS is a consensus-based, community-driven project, and it capitalizes on existing conventions, existing software tools, and things like that. We're not trying to reinvent the wheel here. And there's a big emphasis on simplicity, readability, and accessibility. Something like this won't work unless it's easy to use and widely adopted. And so you have this kind of balancing act between creating something that is both machine readable and human readable. And BIDS really developed out of the OpenFMRI data sharing portal and repository that has evolved into the Open Neuro data repository. And when you start to share data like this, you begin to see just the importance of creating a standard of basically all of us speaking the same language when it comes to the data that we're trying to share and analyze. And just a little extra credit here. Pointing towards the FAIR principles, and this is a kind of ideal put forward for data sharing and reproducibility and things like this, saying that these data like this should be findable, accessible, interoperable, and reusable. And I think that BIDS actually takes us quite a long way in this direction, living up to the FAIR principles. One more thing that I'll point out here is that all of the little references that I have in the corner here are also clickable links that will take you, that have the DOI, will take you to these papers if you want to read further about any particular topic here. What's the point of all of this? I've spent some time of my life kind of trying to convince other people to switch to BIDS. There's often a lot of friction or pushback or things like this. The way that I like to start this, start that process is by asking, have you ever actually tried to reanalyze someone else's data? It's extremely challenging, and I'll go ahead and say, even trying to reanalyze your own data, from a year ago, from 5 years ago, can be very difficult. I know that I have data sets from, that I collected in 2015 or something like that. I want to go back and reanalyze that data set. It's basically like starting from scratch. I have to figure out what kind of crazy heuristic I used to organize the files. What was the input to output to this and the output of this script? Again, it's sort of like relearning whatever idiosyncratic language you were thinking at the time. And one of the main goals of coming to this shared language in terms of data is feeling confident in the data, in other people's data, and using other people's data, being able to trust other people's data, not having to email them constantly asking, like, why is this named this, or which one of these is the right one, or why is this organized in this particular way. The data set should basically be the metadata, right? The data set should basically be self-explanatory, should speak for itself, kind of like live on its own outside of the purview of the data generators or the initial authors. So the initial BIDS paper came out in 2016, and at that time they were saying to date, in 2016, there has been no consensus about how to organize and share neuroimaging data, leading researchers, even those working within the same lab, to arrange their data in different and idiosyncratic ways. Lack of consensus leads to misunderstanding and time wasted on rearranging data or rewriting scripts that expect particular file formats and organization, as well as a possible cause of errors. That's the kind of problem that we're trying to solve here with BIDS. I want to focus for a second on this issue of data sharing. Data sharing is exceptionally important. Public, well-curated data sets have been tremendously beneficial. Think of fields like machine learning, where you have things like ImageNet and MNIST and COCO. These things, not only do these things serve like a really important didactic role in like understanding how to analyze particular data sets or something like that, but these fields tend to, when you have a really good benchmark data set, the field is able to kind of like run up against this data set and build models and test models and compare models. And that's when you see these really kind of big acceleration moments until they completely exhaust that data set, and now it's time for the next really big important data set. And I think we'll see this, we're seeing it already, but we'll see it even more in neuroimaging as data sharing and big sort of consortia become the standard. And I just wanted to point to a statistic from Michael Millam's group suggesting that publicly shared fMRI data sets from the INDIE consortia have saved an estimated $1.7 billion in data generation costs, right? And this is a real humanitarian kind of issue, because that's people's tax dollars that would otherwise have gone into generating what is oftentimes redundant data. And that estimate doesn't even include these huge data sets like HCP, all of the things on OpenNeuro, the ABCD data set, or the UK Biobank, right? So the societal benefits of data sharing are huge. Automated processing is also a really important thing. And there's a recent Nature paper on this really driving this point home, that neuroimaging analysis is very complex and also very flexible, right? It's a multi-stage process with a variety of kind of like a branching paths, a variety of possible analysis choices at each stage, or these researcher degrees of freedom. And putting together a machine-readable standard for data organization like BIDS with this kind of rich metadata allows us to build these kind of automated processing tools. And this is important because it minimizes all the kind of like manual intervention and the way people like will gear a processing pipeline just for the sort of like experiments they typically do or their lab typically does. And the way these tools are made, the way these BIDS apps are made, is that they also maximize the kind of reproducible execution, reproducibility via containerization and moving towards better content tracking as well. And again, we'll get to that more later. Okay, so the initial BIDS paper came out in Scientific Data in 2016 from Chris Gordelewski. But things have, the ball has kept rolling since then. The community has kept expanding the BIDS ecosystem. So in 2018, we have the MEG BIDS standard. The MEG BIDS extension was sort of ratified, let's say. And following that, we have the EEG BIDS and the intracranial or ECOG BIDS data structures that have been finalized and published as well. So you can see that the ecosystem is expanding, and we'll talk more about that later. I am really most familiar with the fMRI literature and BIDS in the context of fMRI. So for this session, I'm mostly going to be talking about the initial 2016 BIDS format for fMRI data. But most of the things that you sort of learn from, thinking about BIDS in terms of fMRI are similarly applicable to other modalities. So when you start working with BIDS, you'll often find yourself, whether you're trying to convert a pre-existing data set to BIDS, or you're trying to start an analysis on a data set that's already in BIDS, one of the places that you'll often find yourself is the BIDS website here. And this is basically where you'll want to go to navigate the bid specification and so forth. And there's a couple things that before we really get into the nitty gritty of the specification, there's a couple things that I'll point out here. First of all is getting involved in bids. Like I said, bids is very community driven, and any one of you could become a contributor to bids in the next couple days over the course of this hackathon. You can be sure that there will be hackathon projects having to do with bids and bids apps over the next day or two. Some easy ways to sort of start easing yourself into this. I encourage everyone to check out Neurostars. Neurostars is sort of like a Stack Overflow kind of thing for neuroscientists, INCF funded question and answer forum. You can check out the bids tag there. Again, these are links that you can click on. And you can also check out the bids GitHub repository. You can raise an issue there if you have questions, or fork it, start making your own modifications, whatever you want to do. But I would really check out the bids code of conduct as well. And then, I had mentioned MEG bids, EEG bids, IEEG bids. These kinds of extensions to the bids ecosystem start in this form of what are called bids extension proposals, or BEPs. And so this is a community-driven model for expanding the bids ecosystem. There's a pretty detailed set of guidelines for how this is, for how the community, how the bids people expect this to be done. Here, I just want to point, I'm not going to go into detail about that. I'm just going to point out here that there are at least like 20 bids extension proposals that are currently under development. And these are just Google Docs, right? You can go look at this Google Doc, you can make suggestions and so forth, try to understand what the current sort of, what people are thinking the way this should work is, right? And if you have some input, you can supply it there. They're doing this for different neuroimaging modalities like CT and PET and NIRS, for different types of derivatives, your functional derivatives, structural derivatives, diffusion derivatives, and for different components of the software ecosystem like statistical models and image transformations and provenance, execution, things like that. So I really recommend checking that out under the Get Involved tab here. I'll also point for a moment to the governance tab here. I keep emphasizing this community-driven development. The way BIDS works is you have a steering committee, you have working groups, interest groups, all of which are democratically elected by folks that are involved in BIDS. And I'll just highlight, this is sort of rehashing things that I've already said, but I want to keep highlighting the kind of central tenets of how BIDS, we want BIDS to work, which is we want to minimize complexity and we want to facilitate adoption. We want to reuse existing methods and technologies wherever possible, not reinventing the wheel. And this is really important. We want to try to tackle 80% of the most commonly used neuroimaging data, derivatives, and models. Trying to get 100% is basically impossible. You can't cover everything. So you want to try to figure out where that, the center of mass is for most of the people that are using these kinds of tools, and shoot for that. And adoption by the global neuroimaging community is the only way that this really ends up working in the long run, right? And so trying to really cast a wide net, be as inclusive as possible, and bring in input from everywhere that we can to try to pin down exactly how we want the BIDS specification to work. Okay, so getting down to business here with the specification itself. Again, you can follow along on the website if you'd like to. I'm going to kind of just walk through things, but the BID specification itself is what's going to take us from whatever, the DICOMs that our scanner is printing out into this nice, both human readable and machine readable format on the other side here. I'll walk through a schematic example of this. I just created this by hand. Of what this BID structure would look like. Keep in mind that there's a whole GitHub repo of like lightweight. These are example BIDS data sets that don't actually have the heavy data in them. It's really just the structure of the data. But this is great if you want to sort of prototype tools that work with BIDS and so forth. So I'd recommend checking out the BIDS examples repo on GitHub. Okay. So what do we have here in this schematic example? The very top level, where I'm just calling it data set here, this is your kind of, this is your top level bids directory. Okay, and within that, you're going to what's highlighted in yellow here are some kind of top level files, metadata, and this includes this participants.tsv file, which I'll show you in a little bit. Tab separated table. It's got participant labels and demographics, condition information, and so forth. A data set description that's in this JSON format, that's kind of like a key value format that I'll show you later on as well. And then some other files like a README that just gives you kind of verbal explanation of what's going on with this data set, and a change log so that you can keep up with what version of the data set you're currently working on and how it has kind of evolved over time. Next, you'll see I have these subject directories here, sub 01, sub 02, sub 03. This is where the real kind of data is going to, the raw neuroimaging data is going to live. In the fMRI case, this is going to be your nifty images and so forth. So this is going to be your subject-specific anatomical and functional nifty images. For the most part, these nifty images are going to be accompanied by what we're calling JSON sidecar files. I'll show you one later on, but these capture the metadata that's not, like, important metadata that's not necessarily captured in like the nifty image itself, like acquisition parameters and things like that. In this example, I also have an events.tsv file. That's really important for, you know, it's hard to analyze a neuroimaging data set if you don't know what was happening over the course of the scan, right? So I'll show you an example of that, but it's really just capturing this kind of like event or block or stimulus task structure that's going on in your fMRI experiment. And then finally, you have some more kind of loosely structured directories for code, your analysis code, for derivatives of your analyses, like from things like from MRI QC and fMRI prep, which we'll talk more about later, and for stimuli as well, if it's possible to provide stimuli. Okay, so that's the schematic example. Let's try like a real life example here. And this is going to be, this is Open Neuro dataset 000233. This is one of my shared data sets, so I'm sort of very familiar with the structure of it. And you can click here if you want to navigate to Open Neuro where this data set lives. Okay, and this little summary here is just telling you, okay, who owns this data set, how many subjects, 12 subjects in this data set, it's about 4 gigabytes. There are 2 different tasks and some different types of files in here. This is actually telling us, this is a little glance at the kind of directory structure that we have here. So you can see a lot of things recapitulated here from the schematic example. You see the change log, the data set description, the participants file, and so forth. So let's have a look at a couple of these. So if we open up this changes, file, I actually cut off a little bit here because I screwed up this changes file at one point. But you can see the kind of release history here, the version history, right? So you see the initial release in 2017, then at some point I added more derivatives and code, and then I wrote a paper about it, and then I eventually added the shared stimuli. So you get some history of the data set here. This is not the most sophisticated way to track the provenance of this data set. These are things that I'm just writing into here. And I'll mention in passing later on a more sophisticated way that we can do content tracking with Data Lab. So that's your changes file. The README in this data set just has a little description and a couple caveats that came up during data collection. Won't dwell on that. This is what the participants TSV file looks like for this data set. We have these sort of long subject IDs here, but that's not really important. You have this column structure where your first column is participant ID, your second column is age, you have a sex column here, and group. In this case, these were all just sort of typical subjects with no between group manipulation going on, or between subject manipulation going on here. So I just have them labeled as controls. Keep in mind that this is like a relatively minimal example. You can fill this out a lot more, right? If you have a lot of other interesting kind of subject demographics, you can fill those out into this participants TSV. If you want to get creative with that, all that the BIDS asks of you is that you also include a participants JSON file that basically tells us what do these column names actually mean. I don't have that in this particular example, but that's sort of best practices. Let's check out the dataset description file here. Yeah, just this is this kind of JSON format, right? If you're familiar with Python, it's very similar to the way that a Python dictionary is set up, where in the curly brackets here you have a key. The first key here is acknowledgements, and that key is colon attached to a particular value, which is the acknowledgements section for this data set. You have another key that's like the authors, which has a list of the authors, and so forth. This is actually, on Open Neuro, it's reading this data set description to populate the to render the web page for the data set with the correct information. Okay, so that's a lot of this kind of top level metadata here. We can dig a little bit further in. Let's skip down to subject RID 00001 here. And so inside this subject's directory, again, this is not derivatives or anything like that. This is just the raw nifty images for this subject. We have a split between anatomical and functional data, so anat and func. If you were to have field maps or diffusion or all sorts of other things like that, these would be in separate folders here, but here we just have anatomicals and functionals. So let's have a look inside the anatomical directory here. There's some strange things in here that I wouldn't worry about, but the main thing to keep in mind here is we just have this anatomical file sub RID 00001 underscore T1, and it's a gzip nifty. You'll notice these file names also sort of share this key value kind of structure here. So each key value pair is separated by an underscore, and the key and the value are linked by a hyphen here. So sub is a key for subject, and this subject value is RID 00001. And this file ends in this kind of suffix that is T1W, just indicating this is a T1 weighted structural image. Okay, have a look at the functional directory here. You see a lot of similar things, right? So here's your functional nifty image. Again, you can see this kind of key value structure in the file name here. You have sub RID 00001. You have a task key that is, in this case, has the BEH or behavior value. You have a run key with run1 is the value, and then it ends with this bold suffix. Here you can also see these JSON sidecar here. That's just the same exact file name, but with .json instead of .nifty.gz, and you have the events.tsv accompanying this file as well. So let's look for 1 second at this JSON, right? So this is a key value dictionary here, and it just has a lot of important acquisition parameters and things like that, right? So we have the repetition time or the TR here, the task name for this particular acquisition, the echo time or TE, the flip angle, the slice timing, and so forth, right? This is all the information that in an ideal world you would be reporting in the methods section, following the OHBM's COBITIS guidelines or something like this. You want to put all of that into your paper, but it should also live alongside with the data set so that it can be machine readable as well. We'll also have a look at the events.tsv for this acquisition. And you'll see this was a kind of, this was like a pretty rapid event related design with, so at 12 seconds, the first stimulus appeared and it was 2 seconds long. And the trial type for the stimulus was an ungulate, some kind of like a deer or something like that running. And I have the condition information here, like the taxonomy is ungulate, the behavior is running. The task that they're doing for this entire run is behavior. This is not a repetition trial. A repetition trial does occur later on. It's a behavior repetition, and you can see that the subject correctly responded, or the subject responded to this with this particular response time. So this is what allows you to really analyze this data set. Otherwise, it's just a sort of time series of fMRI data with no real structure to it. Here you have all of the events. This is what you would use to build your design matrix for your GLM or something like that, or to decide what stimuli, what patterns are going to correspond to what stimulus for your classifier and so forth. Okay. I'll touch on the last, there's at the top level, there's also these other folders, derivatives, code, stimuli, things like that. These are not strictly necessary, but some data sets will have them. So in this particular data set, we do have some MRIQC derivatives. So you see this MRIQC directory that's living in the derivatives directory. For this data set, we included some code along with it, right? So we have a Python script here that compiles our events. We have a Python script that compiles our stimuli. We have a Python script that prepares the anatomy, like defacing these images and so forth. And then with this particular data set, we also provided the stimuli. For this data set, these stimuli are actually like silent clips, right? So here's, bird eating number 2, which is this hummingbird at a flower. And here is bird, here we go. Bird fighting number 2, which is these vultures fighting. Including the stimuli along with the data set is not always possible due to copyright issues and things like that. But particularly in the context of naturalistic data sets, movies and stories and things like that, it can be really important. It can be really helpful to share the stimuli as well, because those stimuli are so rich and there's so many kind of features that you can extract from the stimulus, so many models that you can build based on a naturalistic stimulus. And if you don't have the stimulus, it's hard to do much. Okay, so that's our example data set. I'm going to switch gears for a second here and talk about converting data to BIDs. A lot of people, I already collected an fMRI data set. I didn't format it according to BIDs. Now I have to go share my data, because the journal demands it or the funders demand it. I have to go back and reformat the data according to BIDs. I'm not going to go into details about this. There are a bunch of tools out there that can help this process, like HudiConv and DCM2Nix and PyBids. But yeah, this can be a kind of annoying process. I've converted a lot of my own data sets and other people's data sets to BIDs. And usually it just boils down to, okay, person X in the lab has their own idiosyncratic way of organizing data. I really just need to build some little script or heuristic that takes their idiosyncratic data structure and converts it to BIDs. And that's the worst kind of script to write, because once you get it working correctly, it's important to sort of do it programmatically and to keep track of what's going on, right? But once you get that script working directly, it's basically like a single-use script that's manually tailored to that particular data set. That is not ideal. That's the hard way. The easy way, however, is to use some kind of pre-specified naming convention when creating program cards on the scanner console. And this can allow you to do automated conversion to BIDs. This is not, I'm not sure that this is, that some kind of standard like this has been developed for all sorts of scanners, but for Siemens scanners, we have this repro-in heuristic, and this was created by Matteo Visconti di Oleggio Castello and Jarek Halchenko. And here you can see this just a little schematic here. Basically what you're doing is if you follow a certain structure in actually creating the program card on your scanner console computer, you can then feed that into a program that does conversion to BIDs like HudiConv, and it can understand, okay, this is following the repro-in heuristic here, so I know how to convert all of this automatically to BIDs. And I cannot recommend this process enough. If you're using a Siemens scanner, I would, the next time you start collecting data for a study, I would try to start collecting data in this particular way. Jarek and Matteo set this up at Dartmouth, and at Dartmouth, data comes hot off the scanner. It is immediately version controlled with DataLad. It is immediately converted to BIDs. They can even run MRIQC and things like that in an automated fashion right off the scanner. And that really helps people out, really facilitates data sharing as well. At Princeton here, I think the vast majority of people that are now scanning at Princeton are also using the ReproM convention and converting with and doing automatic bids conversion with QtConv. So the moral of the story here is that, start thinking about sharing and standardization from the start. You will save yourself so much time and pain if you just sort of like do it right from the beginning, with sharing kind of like in mind, right? Because in most cases, you're going to have to share it anyway at some point, based on the journal or the funding source and things like that. So best to kind of like take care of that as early as possible, so you don't get to this like way down the road, have to go back and change everything, and do my analyses still run now that I reformatted all the data and so forth. That's a nightmare. Try to start the standardization process as early as possible. Okay. One more important thing here is when you're converting data to bids, right? How do you know that you've done it correctly? How do you check your work, so to say? And so the bids validator is kind of a bids app in itself, right? But really what the bids validator is doing is it's a lightweight tool for ensuring that your data set is bids compliant. There's a browser-based version of this, but you can also do it locally with NPM or Docker, Python, etc. Again, if you click here, this will take you to the link where you can point the browser to your data set. Bear in mind that your data set is not ever being uploaded to the internet or anything like that, because that would presumably violate a lot of people's privacy and things like that, right? It is a browser-based application, but it is running client-side locally on your data. So that's how you check that your data, the data that you've converted is sort of bids compliant. I had foreshadowed this once or twice before, but anybody who does programming with Git and GitHub and things like this, you start to understand how critically important version control and content tracking and things like that are for both like keeping track of your own code and maintaining a sort of like provenance, like the history of what's happened to your code, and also distributing your code, like sharing your code on GitHub so you can have collaborators who are working on it, or you can package it nicely and distribute it. DataLad is, I would point you to DataLad as the sort of go-to tool for doing a similar thing to what Git does, but for data instead of just code, right? You can't upload a big data set to GitHub, of course. And so this is the kind of problem DataLad is designed to solve. And the way that DataLad basically uses something called Git Annex under the hood, which is going to be tracking the content and changes to your data set. And so you can, as you can see here, this is a kind of Git log for all of the changes that I made to a particular data set with DataLad. You can run code with DataLad such that it will track sort of the code that you ran and what the sort of input output of that code was. And DataLad also serves as a distribution for data sets. So DataLad, I think, is currently crawling some 240 terabytes of data that is hosted in all sorts of different places all over the world. So in that sense, DataLad is both kind of like a content tracking or version control system, and it's also like a data distribution in the same way as like a software distribution, in a similar way to a software distribution. Adina Wagner and Michael Hanka and Yarek Halchenko, some of the main DataLad people, they have, Adina in particular has put together this beautiful DataLad handbook, which is just one of the coolest things I've ever seen. I would really recommend checking that out for both a really kind of intuitive guide to learning DataLad, but also just like a very exhaustive, amazing resource as well. Okay, so that's bids in general. Now we're going to start talking about some bids apps. This is a PLOS computational biology paper from Chris Gorgolewski introducing BIDS apps, how the sort of philosophy behind them. And this paper also included, I mean, there's some, I don't know, there's many BIDS apps at this point for all sorts of different things. We're going to be focusing on 2 of them. But to kind of understand what a BIDS app is about, right? So the machine readable BIDS format enables this kind of automated processing via BIDS apps, right? And BIDS apps use containerization to facilitate portability and reproducibility. What is containerization, right? Containerization is a way of packaging software such that all of the dependencies and things like that are encapsulated in one single image. This is super important for reproducibility because you don't want, just using system-wide installations of software that are kind of, reaching into whatever, grabbing whatever environment variables, right? That really difficult to kind of reproduce software ecosystems that are set up like that, right? And so containerization kind of tries to tile this into like a tight container with, a version history and things like that. So, if I get this BIDS app from here, I'm 100% sure of what is sort of going on in this BIDS app when I run it. And even, ideally 10 years from now, I can grab the same version of that BIDS app and try to run it, and it should behave in the same way because it's ideally not using things from outside of the container in the analysis process. So the main containerization solutions that or technologies that we use are Docker and Singularity. And so you can think of like what goes into creating like a Docker image or a Singularity image is basically a little recipe that specifies the computational computing environment, what needs to be installed, where is it, what version, where does it get installed from, and things like that. It builds it up, okay? And then you have, that's what's represented here with these little BIDS apps that you have continuous integration for testing and things like this and validation. They live on Docker Hub. And then these Docker images, if you're just running it locally, you can just use Docker to run it, and it should be relatively robust to different sort of systems, OSs, environment variables, and so forth. And then if you're, people typically, you're not using Docker on a server because of certain ways Docker is set up. Singularity is the tool that provides the analogous service for multi-user servers. And I'm actually going to mostly give Singularity examples here because I'm not usually running things like locally because the data is just too big and my poor laptop can't handle that. I'm running something remotely on the institutional server. And when you're on the institutional server, it's going to be Singularity. Okay, so our first example BIDS app is going to be MRI QC, which is a automated sort of quality control package for BIDS formatted data. They have this initial PLOS1 paper, and they also recently had a scientific data paper come out. One of the cool things about MRIQC is that when you run it, if you don't opt out, right, but when you run it, it's actually logging the kind of quality control metrics that it's digging up out of your data, such that we can eventually have a big sort of repository of these sorts of metrics, so we can know like what's good, what's bad, and so forth. So that's in the process of being aggregated. If you were to build a MRIQC Singularity image, it's basically as simple as this: Singularity build. This is the name of your Singularity image here. You're pulling it from Docker Hub. PullDrac Lab has a page on Docker Hub, getting the MRIQC in here. I'm specifying a particular version 0.15.2. Okay, I'm going to do a total sort of side thing here because I want to talk about another one of my data sets. This is totally self-serving advertisement here. But this is the data set that I'm going to use to show you examples of these BIDS derivatives from BIDS apps. This is the narratives data set that is currently on OpenNeuro, but I'm still in the process of kind of expanding this particular data set. This is DS002345. There's over 300 subjects. We should have another batch getting us up to 345 subjects coming relatively soon. There's something like 20 plus different audio-only stories that participants listen to with this data set, and we provide the stimuli as well. So anybody who's interested in natural language processing and things like that, semantic representation and so forth, events representation, I think this will be a very useful and helpful data set of naturalistic story listening. The other thing that's nice about this is it's a bigger data set, right? Like this is a much sort of heftier data set to kind of show you the capabilities of this. And what I find completely amazing, right, is that you can point something like MRIQC to this directory that contains all of these subjects and just say go, and it will, unless you screwed up the command somehow, right, it can just understand how to do quality control on this data set with essentially no further input, right? You just say MRIQC subject 1 for me, and it reads all of the metadata out of those JSON files. It decides whether it needs to do this or that kind of processing step and gives you the QC results. So yeah, there's a bunch of, I had sort of mentioned this before, there's a bunch of stories in here, lots of subjects, something like 150 hours worth of fMRI data. So I recommend checking it out if you're into that kind of thing. So what is the MRIQC output for this kind of data set? And here is the example that I'll show you. Now, this image here is also a link. And if you click this link, I have set up a GitHub repo that has, you know, the minimal example versions of these QC outputs that you can look up. If you click this link, it's actually going to take you to the HTML kind of like a preview of this. But what's cool about that, you can't see that here, but is if you hover over these points in that, if you actually open this HTML file, you can hover over these points, see which runs they are, see what various different things mean here. So it's kind of like an interactive plot. But in general, this is just the group sort of structural report for all of these 300 subjects. I won't really go into detail with this. I also have as an example here the group bold report, so for the functional data. And you can see some kind of interesting things here. So for example, if you look at like the TSNR here, it looks like we have a median TSNR around 50. I don't know if that's good or bad. You can look at the frame-wise displacements that we have here. Again, hard to say whether that's good or bad for you. You can look at the smoothness of the images that we're working with here. The SNR of these images, one thing that's kind of funny about the SNR of these images is these high SNR ones are collected, you know, from an older scanner using sort of older style acquisition parameters. These ones with lower SNR are, you know, newer scanner, fancier acquisition, you know, multi-slice acquisition with smaller voxels and so forth. There's a ton of information in here. All of this information is also kind of represented in TSV files in like tabular format, right? So you can really do whatever kind of analysis. This is just their kind of like built-in visualization of this, but you can do whatever sorts of analyses that you want here. So this provides you a lot of kind of quality control metrics. And I am not exaggerating when I say that it is like one line of code where you just point to the bids directory and say, give me subject 1 or give me the group or something like that. And it does all of this and generates that for you just based on the bids metadata. Even more advanced is the second bids app that we'll be talking about here, which is fMRI Prep. And fMRI Prep is a pre-processing pipeline for functional fMRI data. This is functional MRI data. This is also from Oscar Esteban. And they also have a very recent, hot off the presses Nature Protocols paper about analyzing task-based functional MRI data that were pre-processed with fMRI prep. These images are links. You can click on them to get the DOI, which will take you to the papers to read. Oops, I have a typo here. This should be getting the fMRI prep Singularity image. But so similar to before, the way that I would do this, Singularity build, get an fMRI prep image from Docker Hub, Poldrack Lab, specify whatever version you want. If you don't specify a version, it's going to give you the latest version. That's fine too. I'm just being a little extra verbose here. Okay, so I'll use fMRI prep as our example of kind of like digging a little bit deeper into how a BIDS app, you know, what the kind of like inputs to a BIDS app are, and how you would run this with Singularity. So the kind of the quoting from the paper here, fMRI prep is a functional magnetic resonance imaging data processing pipeline that is designed to provide an easily accessible, state-of-the-art interface that is robust to variations in scan acquisition protocols and that requires minimal user input while providing easily interpretable and comprehensive error and output reporting. fMRI prep, you can think of it as fMRI prep will take in your raw nifty images and it will do things like align, do volume correction to align each volume that's acquired over time in the functional images, align those to the T1 image, and potentially do things like slice timing correction, potentially do things like anatomical segmentation into CSF and white matter, and also full-on free surfer reconstruction and surface projection and things like that. And ultimately, it's going to push your data into some output space, like MNI space or FS average surface space or something like this. There's basically two main outputs that you get. Well, there's all of this sort of visual error reporting and QC and things like that. But in addition to that, the two kind of main outputs that you get from running fMRI prep are a bunch of confound variables that were extracted over the course of pre-processing. So that's things like head motion and the derivatives of head motion and frame-wise displacement, and things like anatomical comp core, and so like principal component time series from your CSF and white matter and so forth, global signal, and motion outliers. And so it gives you a giant table that has all of these things, all of these confound variables in it, so that when you go on to your GLM or you're doing resting state or something like that, you have this whole list of possible confound regressors that you can choose from to try to regress out or model in your data. And then in addition to that, it provides the actual data themselves in whatever output space or spaces that you specified. Okay, so what is the simplest kind of fMRI prep command look like? This syntax here is really the case for all BIDS apps, right? Which is that you have this, you have like the initial fMRI prep program that you're going to be running, or the executable, or what's really in this case going to be like a Docker Singularity image. You have in green here the BIDS folder, like the input directory. And you have in pink here where you want the output to end up. Typically, I would be putting this inside derivatives inside my BIDS directory. So the output folder is going to be a subdirectory called derivatives, or derivatives fMRI prep, inside your top level BIDS directory. And then you need to specify either participant or group level analysis. And this will depend on the kind of BIDS app that you're using. In the context of fMRI prep, you're typically going to be doing, it's a participant level, within subjects analysis. MRI-QC is actually a little bit different, right? Typically you want to run MRI-QC on each of your subjects at the participant level. And then after you've done that, you can run MRI-QC again, specifying group, which will aggregate across all of those individual subject runs of MRI-QC and give you that group plot like the ones that I showed you. So this looks relatively simple, but it does get a little more complicated when we take into account Singularity and things like this for running on a server. So here is my example of a kind of fully functioning Singularity command to run fMRI prep. So the purple here is really just calling Singularity. We're doing Singularity run here. We're using this clean env flag because we don't want Singularity to be sucking in any outside environment variables and things like that we don't really are not keeping track of, things that we don't know about. So we use clean env. Here I'm binding whatever my bids folder is outside of the Singularity image, and I'm just calling it data inside the Singularity image. And then I'm calling Singularity on where my fMRI prep Singularity image lives, which is here. I'm just sort of, it's my home directory of sorts where I have my fMRI prep version 20.1.0 Singularity image. So I tell Singularity, take in these flags, run this fMRI prep Singularity image. And then everything that's following that is a bunch of fMRI prep arguments, okay? The ones in green here are the keyword arguments for fMRI prep. So here I'm specifying a participant label, just run participant or sub 001. I'm going to use 8 cores, and I want outputs in T1W, FS average 6, and MNI 152 nonlinear 2009 C asymmetric spaces. One thing that's nice about fMRI prep is however many of these output spaces you list, it will just give you, it will run and give you all of them, right? So you will get outputs in all of these different spaces. You can ask for 1 or you can ask for half a dozen, whatever suits your analysis. I have a couple other things here that are not that important. Here I'm using the sort of field map less field map correction with this use sin susceptibility distortion correction. I'm pointing to a FreeSurfer, FreeSurfer license file. I'm specifying where I want the work directory to be. And keep in mind that for fMRI prep, the work directories can get pretty large. We're talking many gigabytes. That's something, you want to keep those while you're still sort of like, working on analysis and potentially rerunning fMRI prep or something like that. But down the road, you'll likely want to get rid of those work directories so they're not taking up so much space. And then finally, in this big command, we get just those positional arguments, which is the input data set, the bids data set. And here again, this is the name of the data set as I have bound it inside the Singularity image. So it's called data because I called it data. We're saying, put the outputs in data / derivatives and do this at the participant level. So that's your example of an fMRI prep command. And I'll just spend a minute here before we wrap up to look at what these fMRI prep outputs can be. And again, this is on GitHub, so you can navigate to this as well. I'll have the GitHub link at the end of the, you'll be able to find the GitHub link as well. So when I click on this, this is going to take me to a HTML rendering of the fMRI prep outputs. And so I can see here at the top, I have a summary. I have 1 structural image that's T1 weighted. I have 3 functional scans, 2 PyMan runs, and 2 tunnel runs. These are from the narratives data collection. So these are both story listening data sets. And here I'm asking, in this particular case, I'm asking for output spaces as standard spaces in FS average and this one, the sort of newest, fanciest MNI 152, and then an older MNI 152 that's sort of common for FSL people. Also some other output spaces. It's telling me here that FreeSurfer, fMRI prep also ran FreeSurfer in the process. So I have this input anatomical image, and here's all of the kind of cool QC and visualization that I get with fMRI prep. One of the main concerns that people have when they look at fMRI prep is it's like, oh, well, if it doesn't require manual intervention, then how do I know what it's doing? It's like a black box or something like this, right? And that is not the right way to think about it. First of all that kind of manual intervention introduces all sorts of errors and allows you to kind of like weirdly fine tune your analysis pipeline in ways that maybe you shouldn't. fMRI prep does that automatically based on sort of these community driven standards and heuristics. And fMRI prep is what we call a glass box, right? Which is that all of the code is, fMRI prep has exceptionally detailed documentation. All of the code, you can introspect any of the code, all of it, all of the errors are tracked. And basically at every stage of the analysis, you can see sort of what the inputs and outputs were. You can see the sort of, graph structure of the workflow, and you get all of these beautiful visualizations of what's going on at each stage here. So this first one here is tissue segmentation of the anatomical file. Some of these don't render well based on the GitHub way that I did this. Here you can see the surface reconstruction, where you have like the red line outlining the peel surface and the blue line outlining the surface of the white matter. Everything in between there is what will end up as your free surface. This one looks pretty good. These data are, I don't know, 5-7 years old. So this is not too bad, I would say. Here we get into the functional outputs. So again, you have a bunch of details here, like the TR for this was 1.5 seconds, phase encoding direction was anterior to posterior. Here I did the field mapless SYN-based correction. And here is this giant list of all of the confound variables that were created by fMRI prep over the course of pre-processing. Again, some of these images, some of the moving images don't show up in the way that I have this rendered right now. But you can see how this is, we're going to segment CSF and white CSF here to get a mask that we're going to use to create the AComp core regressors and so forth. Variants explained by the AComp core regressors. And then a really nice summary visualization here of some important quality metrics like global signal and frame-wise displacement and stuff like this. You can see, that this subject towards the end of this run had like a pretty nasty, jerk of their head. And this is very evident in the carpet plot here. We can see it's not too bad, but then there's a big here towards the end. fMRI prep provides you this correlation matrix amongst all of the nuisance variables, and then we go into this for the other runs. Okay, so you can sort of explore that to your heart's content. That'll be enough for us, I think. And so I'm going to wrap this up here by, again, just trying to reemphasize that, if we want a more collaborative, scalable neuroimaging, we need data standardization. Data standardization is the linchpin for this kind of reproducible, scalable neuroimaging. And so BIDS, I think, BIDS is the top contender for this, and I think that's the way it's going to be. Community-driven standard for organizing neuroimaging data that facilitates sharing and automated pre-processing. BIDS apps are portable software containers that capitalize on BIDS format to reproducibly analyze data with minimal manual intervention. I have a couple links here at the end. This points to the GitHub repo where you can look at these outputs and things like that. There's a Zenodo, there's like a PDF of these slides in case that's useful. And there's all sorts of other resources out there for understanding BIDS. I didn't create this talk from scratch. I was just looking at other people who have given similar talks. So from the Center for Reproducibility folks and all these other BIDS presentations that are available on OSF. And then just to bring up that I am personally funded and giving this talk kind of on behalf of INCF and Repronym. So feel free, I put my email at the beginning of the slideshow, and I'll be on the Brainhack Mattermost. So feel free to contact me if you have questions or want to hack or things like this. I hope you got something out of that. Alrighty, thank you. Bye-bye.
All right, I got my little magic. See?
Hi everyone. So we're going to start the CONP session very shortly. I'm waiting for my hackathon co-host, Eduardo, who is not here. Oh, there he is. Inviting him on screen.
Okay.
So
Awesome. Hey. Cool. So with us today, we have Tristan Glitard, a professor at Concordia University, and Samir Das, who is the head of the LORIS team at that's part of the McGill Center for Integrative Neuroscience. So they're going to be giving a presentation on behalf of the Canadian Open Neuroscience Platform. So I guess I will exit in this case, or Eduardo can exit, either one of us. Maybe Eduardo? Okay, cool, because we need one of the screens for sharing, for one of you to share your screen. So Samir,
Okay.
you said you're going to go first?
Yeah, sure. I'll go first. And so thank you for having me. Let's see if I can figure out how. I'll just dive right into the screen sharing since I should not any longer make jokes, right? So no more,
I mean,
no more appropriate stuff.
Appropriate jokes are allowed. I don't know if you're capable of making appropriate jokes. I mean, that's like a different issue, but I'm kidding.
All right, here we go. So I'm just gonna share my entire screen because I have a couple of windows. Let's see how this. Okay, so hopefully you can see my screen. Can you?
Yep.
All right, so the idea is that today Tristan and I are going to actually demonstrate what the Canadian Open Neuroscience Platform is. We're going to go through this live. I mean, seriously, what could go wrong, right? And we're going to kind of not only show like what the portal that we built, this website that we built looks like, but we're also going to go through some of the technical technical details in terms of how to actually, get data, use the portal, all that kind of stuff. So that's the basic idea. I can just I'll preface this with a little bit of history. So when we first got this grant, almost 3 years ago now, the idea was to do open science across the country, across Canada. It wasn't necessarily restricted to Canada, but it was a Canadian product. And my initial plan was actually to extend something like LORIS to handle this. LORIS has done all sorts of, data, served data over the years to all kinds of different groups, and so it seemed like a natural place. JB came up with a very innovative plan of actually using something called DataLab, a brand new piece of software that Michael Hunke and Yaroslav and others have come up with. And so it didn't take them very long. It didn't take JB very long to convince at least me that this was a wonderful idea. If for no other reason, I get to hang out with Yarek and Michael, so that was kind of nice and fun. So Tristan and I are going to take you through exactly what we've built. And in the last about 3 months ago or so, I think we actually launched the portal itself, the live production version of this portal. It was a lot of work. There was all kinds of different software ideas, integration of all of this together using some existing infrastructure as well as using newer tools like DataLab, as I mentioned, which is very good for distributed data sharing. And I also echo Sam's previous comments about the need for standardization. This is a very important key part of the neuroscience world. A lot of the tools in the past did not fully consider the ideas of data sharing. And so we're starting to see this new innovation of software platforms that are taking into account things like bids or other standardized or data sharing efforts, right? So there's a lot there. I will spare you the lecture of all that because I could talk about that for hours, but we'll go dive into the portal itself. So for those of you who are newer at either data sharing or even computing, it's quite simple. You just go to portal.comp.ca, that's the website, or you just go to comp.ca, and that takes you to the overarching view of what comp.ca is. Once you get to the actual portal itself, which is the bulk of the technical talk today, the demo, it'll ask you to accept a certain terms of use. This terms of use is also took a fair bit of time to come up with. It's complicated. You know, we're dealing with privacy of, you know, patient privacy, data privacy. We're dealing with website privacy, ethics. There's all these different aspects that come into this. So this is the version for the portal you accept, and basically you come up with this version of this view of the portal. So it has some, you know, very quick statistics about what's on the portal. It has, you know, little about sections that tell you what CONP is all about, with all kinds of tutorials. The dashboard, we're going to elaborate on this more and have different kinds of analytics on the dashboard itself to give you an understanding of what data sets and pipelines actually exist on CONP. So, like, in a nutshell, CONP is an aggregation of both data and pipelines, and it's much more than that, right? So it's not just a registry where you can register data. It's a means of sharing data in an open way. When we can't share data openly, there are some additional layers that we will be adding for either registered data access or controlled when it absolutely has to be controlled. But this is by definition an open platform. So it embodies all the open science principles that the HBM hackathon itself has been built on, and are now starting to gain a lot of traction in our community. So this is the idea behind it. We'll take you into more details about exactly what you can find, how you can upload data, how you can download data, how you can use a lot of the software tools. We even have plugins to high performance computing environments. So these are all key concepts and very important to go. So if I'm going a little too fast, Tristan, I'm sure will, you know, whip me and make sure that I like give you the right amount of time to ingest what we're doing here. But I'm taking you to the first part of this conversation, and that's the data itself. So there are
maybe
ways
just Samir, before we move on with that, maybe we can, you know, just take a few seconds to make sure that people who want to follow this live can actually connect to the portal and you know, find it and follow what you're doing. And in the meantime, maybe we can take one or two questions while people are setting up. If there is any question, feel free to ask them in the
I
chat.
like the way you're handling it. Yeah, is anyone unclear about the concept of what this portal is? So far,
No
so good.
questions?
All right.
Does anyone want to make fun of me? Thank you. All right. So,
question.
Hold on.
Yeah. Okay.
I was just going to say, question from Eduardo. He asked, can you mention how it differs from other platforms such as OpenNeuro?
So it differs in, okay, so we're trying to do the same mission. We're not necessarily competitors of OpenNeuro. We'd like to think of ourselves as collaborators. We do similar things. So OpenNeuro shares data. That's one of the ideas behind it. It also builds on standardization efforts that we've all been part of. But CONP is, first of all, Canadian born. We like to do our own things a little bit too. And also it's leveraging not just data, but also pipelines. And I think OpenNeuro is moving in this direction as well. So in the future, we may have more interoperability between those kinds of platforms. But I guess we're doing it in our own unique way. So that's the short version. Tristan, I don't know if you have anything to add about that.
Yeah, just maybe to one technical difference is that if I'm not wrong, in OpenNeuro, we can only put bits data sets, and there are very good reasons for that. In CONP, we chose to be a bit broader for the good and the bad, but you can share any type of data set in CONP.
There's another question as well. So Catherine asked, with the sort by function, one of the options is origin. What does that mean specifically? University, location, or country?
Maybe Samir, maybe then you can go on with the demo of this page.
Yeah, I guess
And
that's probably a perfect segue to the actual demo. So what we have here is a portal that you can search existing data sets. Right now, there's about 33 data sets here, and given the fact that we've released this just about whatever it is, 3 months ago or so, it's not bad to have already 33 data sets in here. There are some key data sets, like, for example, Prevent AD, and we even have a Prevent AD bids release, which I'll take you through specifically. We have other kinds of data, like I'll probably show you assignment data, or there's also some silly individual has decided to scan themselves to become the most scanned human being on the planet. So you have to question that person's judgment, I would say. But the idea is that we'll go through things like these data sets, and the sorting, I believe the origin part to answer that question is where the data came from. Like, so we have the different centers and places, you know, where they were created, and so you can sort any number of ways by the date added, by the disk. We can even add. As this is an open platform, we're open to suggestions of what kinds of sorting functions or other capabilities we might be lacking. So feel free to make suggestions, and I'm sure we'll integrate them. You can do that directly in GitHub. There's a CONP GitHub page that's open, or you can email us or whatever. So that's the idea here. Basically, if you were to click on any one of these, let's go to Simon data. This is about 100 scans on one individual that has been done, and it's released openly. And so there's some meta information, and a lot of this is automated. So back to the previous point about having stuff structured and automated, we've come up with something called a DATS file that basically gives a project description in a very organized way. You can download that right here. And then on other fronts, we have a lot of this information being displayed. And so if you click on the link, you can go to the actual source itself, which is kind of important. We also allow for the data sets to be downloaded, and I will kind of take you through this process. Command line, like literally, we're working on easier ways to download this via the web interface, but that's something that we haven't quite released yet. It's coming very soon. But there's instructions that are hopefully very clear. So in order to use this portal, it does have some dependencies, and one of them is DataLad. DataLad also has some dependencies in itself. It's based on Git Annex, which is a very novel idea that sort of is an extrapolation of Git, except instead of for software, it's for data, version control for data in that sense. So Joey Haas is the lead developer of that, and a lot of this has been built on that. So the first thing anyone would need to do, and this is something that we can do over the next like hackathon time, over the next day or two, is install DataLad. I can tell you that they have a very nice website with, if you were to click here, you see exactly what the instructions are, how to get at DataLad. It depends on which operating system you're on. For example, if you're on a Mac like I am, it might require that you download the developer tools, which can take some time to do. So, if you're interested, already start that process. That has OS dependencies and things like that. But once you finally have DataLad installed, to use it is actually quite easy from my point of view. I'm a computer programmer by trade, so maybe that's not, there are some assumptions here for people who have no computing experience whatsoever. What we've done is we've come up with some very clear instructions on how to do this. So literally you can cut and paste this kind of stuff into a terminal. Yes, I use a white background. And what we can do is just, I'll take you through a quick little demo here. I'll start with a new directory. So let's call it COMP test or something. And I'll go into that directory and actually just simply run this command. So this should work. What could go wrong in a live demo? It's cloning. What it's doing right now is it's installing the entire DataLad, the entire CONP Git sort of repo of what data sets we have with all the appropriate metadata describing those data sets. So as you can see, yay, it worked, no big deal. If I was to go into this directory, let's see here. So there are a few subdirectories. Some of this is more technical. Circle CI is a way of validating the data sets that we have, making sure that all the parsing actually works. There's some datalad, and there's some dot files here that are just config files. There's some information README, but there's also a project directory that has we would have downloaded all the different data sets that exist here. So basically, you can see the kinds of data sets that we have. If we wanted to, for example, download the Simon data set, we would just literally follow the instructions as generated, which are unique to every single data set that we have. So if I do this, hopefully nothing goes wrong, but basically it will clone the data, this specific data set. It will clone that repo, and after a few more seconds, hopefully, it'll just have the metadata of this downloaded and working. So now what we have is symlinks in here. If I was to go into this particular project, which is, I believe, the Simon one, and this is what you'll see. So you'll see very quickly the DAT file here. It has some very standardized machine readable information about what the project has. So maybe I took too long, was too quick with showing this. You can very quickly see like licensing information and other kinds of key information about the data set. There's READMEs here. And of course, there's the actual data itself, which hasn't actually been downloaded yet at this point. All we have is the directory tree with symlinks that show exactly what exists. So very much like the bid specifications, we have mimicked a lot of this here to have data in that format. I will just go into one given data set, for example, and what we can do is actually we can do a datalad get of some specific files. So if I wanted, right now the data is not actually sitting on my server. If I was to actually run this and click that command, which is also provided in the website right over here, down here, then you can get whatever kind of data that you are actually seeking, and it'll put it on your machine directly. So now I have this file here, so I can actually, open it, use it. I have this nifty file. There's a JSON file that I could get. So if I wanted to do the same thing for that JSON file, no problem. I would just go, and in a few seconds, nothing goes wrong. Then you will have that file here as well. So this is the idea behind using datalad very quickly, just to depict this. There's all kinds of information that is, also on the website about what we have here. But as you can see, it's pretty easy. You can do this for entire directories. You can do this for huge data sets, and you don't have to worry about a web browser crapping out or whatever. So this is how you download data in a nutshell. So maybe I'll leave it there for a second. Tristan, I don't know if you have anything you want to add to this. I can, if everyone's clear on this, I can then show you how to get something that's more like behind a firewall or password protected data. So, questions, comments? Everyone
while we're waiting for questions, maybe I can share my screen and to prepare for the pipeline part.
Sure. Well, so I was gonna. I guess I don't need to do the downloading of like prevent AD data or something like that, which is just same thing, same procedure. Just that it might ask you for a password. I think we can probably skip that part. But all of that to say that there are some data sets that are, for example, like Open to Prevent AD here is within a Loris instance, and you can go into the Loris instance itself and download the data, or you can get it this way. But it might when you do this command line, it might ask you to actually enter a password and the credentials that are given by whoever is providing the data. So we allow for all sorts of authentication mechanisms or data ownership mechanisms. Some people aren't comfortable sharing their data and putting it on a centralized server. They want to retain access. So there's many ways for us to go about doing this. So I'll leave it there for the moment. Any questions come up yet?
There was one question. So Tashrif had an error on the GitHub repo. I don't know, maybe Tashrif, could you be a little bit more elaborate, or?
Yeah, so what was the exact error, perhaps? Maybe we can include it there, and there's other CONP developers directly on the call. They can actually address it live for you potentially. So
yeah,
that might be a good way to go about this.
There's also another question from Louis. What are the advantages of being a CONP user?
So our plan, and you'll see more about this later, is it's another mechanism to share data. We're part of the data sharing communities. Open principles, fair principles are very much something that govern us. And we have all sorts of other technologies that you haven't yet seen. This is just downloading data. There's uploading data. There's using pipelines and launching pipelines directly on the same servers, potentially where your data resides. There's all sorts of functionalities that Tristan will show you. And so those are some of the advantages, to name a few. Any other questions before maybe we transition over to Tristan's side of it?
There's a question from Sebastian about how would you manage a metadata set made of several data sets with different tasks with DataLad? Yaroslav answered that on the DataLad side already. So DataLad does support sub-data sets through sub-modules in a data set. That's also something that we represent and support in the CONP portal. So if you look at the big brain data set, for instance, if you click on it, you could see that it has some derived data sets, and this is represented in the portal as well.
Indeed. So there's so much more to what we're trying to do and what we already have created. So maybe this is a good time for Tristan to start showing you a lot of the other functionality.
Yep, absolutely. If you can stop screen sharing, Samir.
Yeah, right. I have to do that. Such control. Let's see.
Let me see if I can start now.
How do I?
So, Monsieur, select. Yeah.
Did I close the video? Is that it?
I stopped your screen share already.
Oh, okay, thank you.
Yep. Okay, I guess I'm screen sharing now. It should be coming. I'm also going to assume that we have 15 minutes left. Lisa, let me know if I have to be shorter.
15 minutes is good.
Okay. Can you see my screen now?
Not yet. Maybe if I unfocus your screen. No, it's still not there.
Is it loading or is anything happening on your side?
No.
It says that I'm screen sharing now.
I would suggest maybe just refreshing your browser, but otherwise I can like uninvite you and then re-invite you. I'm not sure. Maybe there's some kind of lag.
It's still loading. It says it's still spinning.
So maybe while that is going on, we can talk generally about the concepts of CONP, maybe other things on that front.
I just wanted to make a general comment on what you said, Samir, that we are trying to serve both audiences of people who really want to use a command line terminal for good reasons and people who prefer to be on the website. So that's why essentially, so data download is currently only available on the command line or the terminal, and we're working on making it available from the browser, but we are really trying to do both things because we think it serves different use cases.
Yeah, so we actually have a roadmap moving forward where we will implement web-based downloads That may have specific use cases that are more ideal. So, like there's a lot of people who deal with large amounts of data. They're not gonna, necessarily use a web browser for that. They're going to go command line, use existing pipelines to process data. It's just about getting access in a standardized and automated way to data. So that's what I've demonstrated partially is sort of highlighting those principles. But we understand that not everyone in the neuroscience community is as technically savvy, or maybe it's a little bit daunting. It's hard to understand. There's sometimes prerequisites. So we'll do what we can to make sure that there are mechanisms to get access to the data regardless. And the portal itself already is web-based. You can see what's there in terms of data sets. That's going to increase. We're going to have connections, I think, with other kinds of hubs. I regularly have conversations with people like Brainlife, Brainlife, or like back in the day with Chris Gorgolewski. I'm sure there's all kinds of open neuro angles, or with Mike Millam. He loves sharing data, so there's that we have collaborations with them to increase this. So there are many future angles coming into this, but we definitely will try to keep it simple for everyone. So,
actually, maybe I could ask a question.
Sure, absolutely.
Maybe other people might have a similar question. So, to my knowledge, Loris used to be sort of like a parallel platform to XNet. But I know that XNet has recently, I don't know how recently, but when I have used XNet for my own research, I've seen that they now give you the option of running a tool on data. So I guess is UNP sort of doing a bit more like that in a way?
So kind of XNet's and XNet's slightly different architecture from Loris. It does similar things in the sense that it handles data. Loris is more like at the core where you're acquiring data through a web browser systematically. XNet's strength has always been, you already have some data and do the processing and pre-processing with it. XNet has come a long way with a lot of their marketplace and other kinds of aspects. Some of what they do is what we would say is more of a C-brain type of task. So together with this ecosystem, it covers overarching similarities as you described. Tristan, you're back.
Yeah, I can't seem to be able to share my screen. I don't know if it's a Firefox thing, but maybe Samir, you can share your screen, and I could comment on that, if that's okay.
Sure.
I drive you.
Okay,
Just
so I'm here. Should we go to the tools and pipelines section?
Yeah, absolutely, but you're not sharing yet.
Oh, right. Let me share. Give me a second. Okay. Can you see?
Yep.
All right, so we're back at the portal. We've highlighted the data side. Now we're moving towards the tools and pipelines, and just now I'll just follow your lead.
Exactly. So just like for the data sets, you can search for various tools and pipelines. We have integrated at the moment about 60 tools. So again, it's not extremely large, but the idea is that we also provide executable tools. It's not just links to tools, it's tools that you'll be able to execute in a consistent way. So we include various tools, including the main toolboxes, including BIDS apps as well, as were presented in the previous talk. So if you search for BIDS, for instance, Samir, you can see that we have a few BIDS apps here which are available. For every you can maybe stay to the first one, for instance, the fMRI prep. So for every tool, we have a general description of the tool. We have various tags, which would allow you, for instance, to search for all. If you click on the fMRI tag, for instance, you'll be able to search for all the tools which are related to fMRI. Yeah, exactly. So the tags are really free-form. It's like, this is similar to a PyPy kind of registry for those of you who are using Python. So it's really like anyone can push their own tool. The tags are created by users, entered by users. They are free-form. So, the search, just to say that the search is a bit fuzzy. One thing which is very important though, so once you're able to look for tools and maybe find a tool that you'd like to use, all the pipelines, which are a synonym for tools, have a permanent digital object identifier, a DOI, so they correspond to a specific entry on Zenodo, which we'll show in a few seconds. So if you look at this ID here, this is going to be a key to execute the tool, and this will be a permanent identifier. It will never change and it will never disappear. So if you want to click on the title of the pipeline, Samir, you can see now more details about the tool, and in particular, we provide different ways to execute the tool. So again, at the moment, most of it is accessible through command line interfaces. We provide a way to run the tool locally. So that's part of the boutiques framework. There are instructions which are, command line, similar, we can show them later, but similar to what Samir showed for Data Lab before. At the right of the screen, we also provide a library called Clouder to run these tools on HPC clusters. So if your HPC cluster supports the Slurm batch manager, Clouder is a set of helpers that will help you, to iterate the tools over multiple data sets and that type of things. Finally, we also provide a link with the CBrain web platform. So we should look at different tools to have it available. Only some tools are available. And what that allows you to do is to be redirected to a web portal, the CBrain web portal, where the tool is installed, and you can just run your analysis from that web portal. So the interface with CBrain is still a bit in the works. I mean, we can link to CBrain, but the tighter integration between, especially the data part and the pipeline part through CBrain is being worked on. So if you scroll down just a little bit, Samir, so we can see the various fields which are available in the description of the tool. Again, this is machine readable. It's available as a JSON format in the backend. All the tools are containerized either within Docker or Singularity for the same reasons as the presenter was mentioning in the previous talk about bits. This one happens to be on Docker. We also support Singularity. Finally, I guess we won't demo it now. I could do that on my terminal easily, but just to say that, so these are instructions, that we've made sure are working and clear enough. This is how to run the tool on your local computer. That would require you to install one Python package called boutiques. You can find more information in other places in the portal. Yeah, exactly. We have instructions here. We have a tutorial, which is also linked right above the first bullet point here. And essentially, so the way the functionality that boutiques provide is to manage containers for you, and also to describe command lines uniformly for you. So you don't have to learn, all the details of every command line option, how they work, etc. You can just type Bosch example, and then after that you recognize the Zenodo ID. I'm not sure if you have boutiques installed, Samir, but yeah. So if you type that, it would provide you, it would create an example invocation for you that you can customize to use your data. That's great. Yeah. So exactly. You could just pip install boutiques, but since we have 6 minutes left, I guess we can skip this part. Of course, we're available to help you. And there is, as I was saying, maybe Samir can hover over the tutorial link, which is right before the first title in the instructions, exactly here. So it's really a step-by-step on how to use boutiques to run your pipelines locally. Any particular question on tool execution?
So there is a question from Sashri asking if you can give a quick demo for running a familiar executable such as FSL bot.
Yeah, that's exactly what I was hoping to do. I'm not sure how to do that without screen sharing, but I'd be happy if you go to the Mattermost channel, hackathon-conp. I would be very happy to give instructions here. So sorry for not, being able to screen share.
So we the sharing aspect before we close out still?
Yeah, I wanted.
I have Bosch installed. I have Boutiques installed. I don't know. I might be able to share my screen.
Sure.
I don't know that.
The only thing is that pulling the FSL bed container is going to take a few minutes probably, because it's 1 or 2 gigabytes.
I think I have it.
But
Okay.
Pretty sure.
maybe we shouldn't necessarily dive into it right now. It might take a little bit too long to set up everything.
Yeah.
We can do that afterwards. We'll be available throughout, like after this and at other times to the hackathons. If anyone wants to try this, they can definitely do it, and we'll be here to help.
Yeah.
Maybe we should move towards how to upload data.
I really would like to talk about data sharing.
Yeah, let's do that.
Yeah. So any other question before we move on?
There was one more question, which was more generally, is COMP interested specifically in MRI data, and I guess even more specifically fMRI data?
No, there is no. I mean, we are interested in this type of data, obviously, but there is no real restriction. We accept any kind of data related to neurosciences in general. So we have genomics data, for instance, Samir, if you want to show, but we have a few genomics data sets, in particular one coming from the 1000 Genomes project. We have EEG data, or at least one example I know of, and we also have tools related to that. So we have bioinformatics tools, and we have tools to process EEG. As I was mentioning before, so the fact that we have adopted a consistent metadata format, but we don't really have, a unique data format or even organization as BIDS can be. And this has drawbacks in the sense that when you download a data set, it may come in any format. But the advantage is that we can integrate data, in a broad way. So maybe it's a good time to move to the last part of this tutorial, which is about data sharing. So how can you share your own data? So we have essentially, still with this idea that some people may want to be, die-hard command lines. They have their own servers. They want to share existing data, and others, may just want to do something through the web. We have the same principles for data addition. So the part that we are not going to demo is the more die-hard or technical involved way, which would be if you know how to use DataLad, if you already have a DataLad dataset, if your data is already hosted on an HTTP or an FTP or whatever other backend which is supported by DataLad, then adding your dataset to COMP is just a few clicks away. Essentially, you can just make a pull request to our GitHub repository. You will have to add a description of your dataset, and then your dataset will show there. What we're going to demo here is the more web-based way to add data. We support two ways to do that through research archives, which are widely used and known. One is based in Europe, that's Zenodo, and the other one based in the US, that's the Open Science Framework. So we're going to demo the Zenodo way. Samir, if you just want to click yes, exactly here. Thank you. So Zenodo is, and while I'm introducing, maybe Samir, you can log in with your GitHub account. If you remember the password, thank you. So Zenodo is a research archive hosted at CERN. They essentially provide almost unlimited storage capabilities for research data. And for individual data sets, it means that you can upload, I think you can upload up to 80 gigabytes of data, with no questions asked. If you have more data to upload, you can just talk to them. So we have actually a crawler, a DataLad crawler, which is able to discover data on Zenodo and add it to CONP. So Samir, if you just clicked on upload, yeah. So here, if you wanted to upload a new data set, you could click on the new upload button here. In the meantime, I will just follow up on Michael's comment in the chat. Yeah, to give a shout out to the DataLad OSF adapter, which is also in the hackathon project, if I'm not wrong. We are not using the DataLad OSF adapter, but we'll certainly do that when it's available. You can click on choose file, Samir, and just to demonstrate that anything can be added here. You can use whatever file you have. If you put a zip file, we would unpack that zip file later on. You can add whatever information you want here. And if you scroll down a little bit to keywords, there must be a field called keyword somewhere. Maybe a bit down. Yes, exactly here. So here the key, the key is to type Canadian, and this is in the documentation. If you type here Canadian-open-neuroscience-platform with no capitals, and this is long intentionally to be discriminative, that's the keyword that will allow our crawler to pick up on your data sets. So we're not going to finish the submission now because time is running short. But just with that, then there is a submit button somewhere that you can just click. If you do that, then our crawler will discover your data set on Zenodo. It will create a DataLad dataset for your files. It will generate a basic metadata information from the fields you have added on Zenodo. And it will make this pull request in our GitHub repository. So this is an easy way, if you don't want to learn, or for different reasons, if you don't want to use or cannot use DataLad, you can just upload your data on Zenodo with the right keyword, and then your data will end up, after review, of course, will end up in our GitHub repository and therefore in the portal. So similar mechanism works for OSF. It's really similar steps with the same keyword, etc. And as I was saying before, it doesn't prevent you, if you're a DataLad user, to just pull request your DataLad repo. Final word before we close this and maybe take final questions. So this was essentially a tour of the platform. Everything's available and documented on GitHub. Maybe before we close, we could say a quick word about NeuroLibre. So Samir, if you want to go to neurolibre.conp.ca, NeuroLibre is an effort from the CONP project as well, an effort to review and publish Jupyter notebooks related to neuroscience experiments. So the platform is very much, being finalized, will soon be announced, and it provides a way to easily interact. It will provide a way to easily interact with the CONP datasets and pipelines, in particular to publish notebooks. So you may want to check that out as well.
Yeah, this has a specific value for the OHBM community because there are potentially efforts that might be associating with NeuroLibre, whether it's something like Aperture, which is an OHBM journal, or just simply the ability to share open data, but also do what is known as data publishing itself. So this is something that's pretty key. It's part of the CONP initiative. It's headed by Nicolas Stikov and Pierre Verlet, and of course others are very much involved in this. So this is something that you will see coming on the horizon probably in the fall. So that's kind of NeuroLibre and the portal. In a nutshell, we have all sorts of FAQs. We've spent a fair bit of our time trying to document this in a way that is as user-friendly as possible. So feel free to try to upload data, download data, use the pipelines, and I think you will see that there is great value in having more of these kinds of platforms available to share open data with the world. So I think with that, unless Tristan, you have any closing thoughts, I think we have kind of given you a rundown. Tristan?
No, exactly. Just to say that we have a hackathon project going on, so feel free to chime in the Mattermost channel or crash into our Zoom for more information.
Cool. So
Thanks all for attending.
Yeah, thank you both. So I think we just have time for 2 questions that are left. So Tashrif has been asking lots of questions. Thank you. The first one is, do you have a size limitation for sharing my data?
No, sort of. I mean, like, so data
I
lab
can take the. Sure, go ahead.
data
Go ahead,
lab
Samir.
is a framework. So it's kind of like whatever the limitations are of where you're hosting the data and the bandwidth issues, if there are any. We also can provide space, you know, depending on whether you need to host data. So there's no like limitation per se, but you may run into logistical problems depending on your own environment.
Right. Okay. Cool. And then the last question is, probably you already mentioned, but is COMP a free service for data hosting and sharing? I heard Samir saying, although a Canadian product, but open to the world or something along those lines.
Yeah, I mean, absolutely. It's funded. This was a Brain Canada grant that was $5.5 million with matching funds, $11 million. And so it was made in Canada. Canada has a fair bit to offer in terms of infrastructure and data, but it's by no means restricted to Canadian data. We have little icons there that show what's, you know, specifically part of homebrewed versus external, but this is a resource for the whole world. It's about facilitating open data sharing for the planet and all researchers. So that's the idea. Just I don't know if you have anything to add to that.
Yeah, maybe just one quick comment. By design, the platform is decentralized. That's why we're using Data Lab. Data can be hosted essentially anywhere. So for this reason, there is no fundamental storage limitation or cost models associated to it.
Awesome. Cool. Thank you both so much. I guess with that, we will conclude the COMP session. Thank you both again. This has been really great. I mean, I knew about COMP, but I still didn't know what all of the different capabilities were, so this was really excellent. Thank you. So we're
Thank you for attending.
Yeah,
thank you for coming.
So we're gonna finish this session, and then I will move everybody over to the Data Lab session that will be taught by Dina Wagner. Thank you.
Thank you.
DataLad is a data management and data publication multi-tool, and I will be spending the next 1.5 hours showing you how it can be used to version control your next project in all aspects, or how it can assist you in the reproducibility of your results. Should you be wondering where I am, I'm in a rabbit hutch. Should you ask yourself, why the hell is she in a rabbit hutch? Then I would say, well, why not? Given that the pandemic limits where we can currently go and the company that we can currently have, I chose to be in the most exciting place with the most corona-conform company I have access to, And this is why I'm joined today by the two cute bunnies, Emil and Nala. You can see Emil munching a carrot right next to me. This has the great advantage that you have the chance of cute bunny content, in addition to amazing data-led content. Don't worry, I'm not enforcing a software demonstration on two innocent bunnies. That would be really cruel. The door of this incredibly large enclosure is open, and the two can leave whenever they want. As can you, by the way. So if you want to leave this train track or mute me, go ahead. I won't even notice. It's a win-win situation. So, from the middle of Germany, in some rabbit hutch, a very friendly hello to you wherever you may be in the world. I hope that you stay safe during this pandemic and that you've made yourself comfortable and brought a computer with you to this train track session. So, let's get started with data-led. There are many different use cases for data-led. One straightforward reason that I use it personally for is to version control all of my personal projects, whether that are data analyses, writing a book such as the data-led handbook, version controlling my CV, creating presentations and videos like this one, or managing my music library. I call this straightforward because one thing that data-led does is version control. Version control means tracking changes made to files over time and having the ability to revert changes or view specific states of a file or of a project's history. Unlike version control with tools like Git, data-led can not only manage small files such as code or other text, but files of any size. This makes it possible to version control 500 gigabytes of neuroimaging data with data-led, for example, or manage my complete music library. But I have more use cases for data-led, and so will you. I, again, use it to create provenance-tracked and computationally reproducible scientific analyses. So when I write a paper, then I use data-led to link data, code, software, and the results, and then I publish all of that to Git repository hosting services such as GitHub to make my work openly and easily accessible to others. And in my home institution, the Jülich Research Center, we use data-led for really large-scale, fair data analysis projects on supercomputing infrastructure. Other common use cases, for example, concern data publication or collaborative work on analyses. And you may have even other use cases for data. It's an incredibly versatile tool. With my demonstration today, I hope that I can give you an idea of what's generally possible and a good starting point to get going with data-led. I won't go into all of the details and I won't be able to mention everything that is possible with data-led. But if my demonstration interested you, then there are resources out there that will get you started with however you want to use data-led. First and foremost, those resources are collected in what is called the data-led handbook. You can find it as an HTML version in a PDF or EPUB format at handbook.dataled.org. This handbook is a hands-on crash course on data-led that you can turn to learn how to use data-led. It's written in a community effort and it teaches you everything you need to know regardless of the background that you have. Beyond a course-like tutorial, the handbook also contains advanced topics, such as a chapter on scaling up. So if you're interested in version controlling projects that are as large as the Human Connectome project or larger, or run analysis on them, go ahead and read this chapter. And it also contains use cases. Those are step-by-step instructions and overviews on the different use cases that data-led assists with. Those can be basic, like a general introduction to provenance tracking with data-led, but they can also be quite comprehensive. For example, how to write a completely reproducible paper, or how to implement a central data management and data archival solution on an infrastructural level for a scientific institute. If you want to find out more, visit the handbook at handbook.dataled.org or come to poster 1914 later at the OHBM. So let's start with the boring stuff. Dataled is a command line tool and it has a Python API. So whenever I use it, I either operate it in a terminal using a command that starts with datalet, or I use it in scripts such as shell scripts, Python scripts, Jupyter notebooks, and so forth. In the command line, this is how it looks like. I always start with a general datalet command, and then I add whatever subcommand I need. And if I use it in its Python API, then this is the line that I would use to import datalet. And you will later see a script where I show you how this is done. Cool. Datalet builds up on two version control tools, namely Git and Git Annex. They both provide the version control features that Datalet offers. Git Annex takes care of handling large file content that Git wouldn't be able to manage. In order to use Datalet, you will need to have all three tools installed, so Git, Git Annex, and Datalet. However, you don't need to know how to use Git or Git Annex. It's completely fine if you have never used Git before. Datalet tries to hide the complexities of the other tools as best as it possibly can. You can find details on how to install Datalet and its dependencies on all operating systems or using several package managers in the Datalet handbook. It also details how to install Datalet on shared machines, such as high-performance compute clusters, where you don't have administrative privileges, so sudo rights. Once you have Datalet installed, we can go right into this train track. If you have Datalet already installed, but you're not sure whether it is an old version of Datalet, please go and check it now. It is important for this train track session that you have a quite recent version of Datalet, at least version 0.12 or higher. You can do this by typing datalet-version into your terminal. If you have an outdated version of Datalet, then the handbook will also show you how to upgrade to the most recent Datalet version. All of that can be found in the section Installation and Configuration that is shown in the slides. Cool. Right after the installation of Datalet, the very first thing that we have to do, if you haven't done so yet, is to configure your Git identity. If you've never used Git, again, don't worry. The identity that we're providing here with the git config command consists only of your name and email address, and it will be used to associate a change that you make in any of the version control features of Datalet with you as an author. So that's a useful feature to have, and if you don't do the configuration, then Datalet will warn you constantly. Now that you have configured your Git identity, we're ready to use Datalet for the next project. So let's dive into the basic concepts and commands so that you can get an idea of how it can be used and what it can be used for. If you have it installed right now, then I invite you during this train track to follow along with me and use the same commands that I'm using. You can find them to copy and paste into your terminal at handbook.datalet.org. In this demonstration, I'm using content from the basics part of the handbook. This part is a code-along crash course, and it follows a narrative that takes readers through a fictional educational course called Datalet 101. So for the rest of this demonstration, envision yourself as a student in this college course, and the examples that I'm using here are thus not really related to neuroscience, but tuned to this college course narrative. But it will not be difficult for you to link your own use cases to the Datalet concepts and commands I will be showing you, because Datalet is a completely domain-agnostic tool. So, the foundation, or the most basic concepts that we have to start with, is the dataset. Everything that we will use Datalet for happens in so-called Datalet datasets. A dataset is the core data structure of Datalet. But honestly, it's nothing fancy. A dataset is just a directory on your computer that you instruct Datalet to manage. And absolutely any directory on your computer can be managed by Datalet. You can create datasets as empty directories and then populate them. You can transform existing directories that already have content into datasets to version control their contents, or you can install datasets from elsewhere to obtain the data that they contain. And even though it's not the coolest feature, or it doesn't sound like the coolest feature right now, datasets can be nested in each other, so you can create a hierarchy of datasets. And I will show you later how this feature is quite amazing. In the narrative of the handbook's basic part, we are students, and in the first lesson, in chapter 1, we are creating a data-led dataset to collect all the course materials of the data-led 101 course into. We will follow this narrative to experience some of the basics of data-led datasets, because it's much easier to just explore the stuff instead of boringly have it explained to you. Creating a dataset is done with the data-led create command. This command only needs a name, and it will subsequently create a new directory under this name and instruct data-led to manage it. Here, this command also has an additional option, the -c text to git option. With the -c option, datasets can be configured in a certain way at the time of creation. You can find out about the details of the text to git configuration in the data-led handbook, but in general, this configuration is a very useful standard configuration for datasets. You can see when I execute this command that data-led informs what it is doing during the execution. At the end of this command, as with any command that data-led performs, it will print a summary. In this case, it is a successful create operation as indicated by this OK in brackets. And right after dataset creation, there is now a new directory on your computer called data-led 101. If we now navigate into this directory with the change directory command, this is this cd command, and then list the contents of this dataset with the ls command, then we'll see that it's empty. That's not surprising, because we haven't put anything inside of it yet. However, there are some hidden directories at work, and those hidden directories are the version control tools that data-led builds up on. And thanks to these version control tools, this dataset has really cool features. For example, a dataset can record everything that is done inside of it. It can version control all content given to it, regardless of how large this content is, and it can have a complete history that you can interact with, check out previous states, revert, and so forth. Even though the dataset is empty and doesn't version control anything yet, this history is already present, and we'll check it out to just get you an idea of how it looks like and get some core concepts known to you. In general, this history exists thanks to the version control tool Git. Therefore, you can access the history with any tool that shows you Git history. Here we say basic and simply use the built-in Git tool gitlog or Git command gitlog. But if you have other tools that you find visually more pleasing, then go ahead and use them. You can visualize the history with whatever tool you want. When running gitlog, it will show you the history of the dataset as git commits. These git commits are shown in a certain sequence. The most recent commit is always at the top. The commits are created every time that you save a change, and they have particular information in them. One important piece is this 40 character string. This is a so-called commit hash or char-sum or checksum, and it's a string that can uniquely identify any given commit in your dataset. You can also see that each commit has an author and a date and a time of the change recorded, and what you can finally see is that there's a short message attached to each commit. We refer to this message as a commit message, and in general it's a short and informative summary of what was done in a particular change. Usually you will need to provide such commit messages, and they are useful for you and others to easily know what was done in a human readable way. The two commits that are currently in your dataset have commit messages that were created by datalet though, because those two commits are associated with the creation and the configuration of the dataset. The reason that this history is accessible with Git tools is that a dataset is a Git repository. It just has some more features than a Git repository, and you will get to know them soon. If you're a Git user, therefore, you can use any Git command of your choice in this dataset, and it will just work out of the box. If you're not a Git user, you can still use any Git command, but you can also use all of the datalet commands that I'm going to show you. Now, because this dataset is really quite boring still, let's put some contents inside and version control them. This first part of the demonstration will show you the general local version control workflows that you can do with datalet on any type of data. Because this narrative contains an educational class, let's put a few books, such as the readings that you would usually get in a college course, inside of the dataset. For this, I'm downloading a couple of books and put them into my dataset. I'll start, to be neat and orderly, by creating a books directory with the mkdir command, just to have a place for those books to live in. And afterwards, I will download 2 books from the internet. Here, I'm doing this with the command line tool wget. It's just convenient for me to do all of this in the command line, even though the command is a bit lengthy and intimidating. It's just a download. If you want to, you can, of course, just go to the web page that these books are hosted on, click on the download button, and save them in this directory. After all, your dataset just looks like any regular directory on your computer, and you can just save a PDF in whatever way you would usually save a PDF into this. The books that I'm downloading here are free and open source. In general, I can recommend them. They are on the Linux command line and on Python programming. And now that I've downloaded them, I can see how my directory structure looks like by running the tree command that shows me the file hierarchy in my directory or in my dataset. Here I can see that there are the 2 books that I've downloaded as PDFs in the books directory. The question is, how does the version control software that is now working in this directory behave now that there is content inside? For this, I'm simply going to ask the dataset what its current state is. And for this, I'm going to use the datalet status command. The datalet status command is a very helpful command that you should use very often. It reports on the current state of your dataset. Any content that is new or changed will be highlighted, and if nothing has changed, the datalet status report will report on something that is called a clean dataset state. And just as a heads up, the clean dataset state is the thing that you should strive for in your work routines. Always make sure that you commit the changes that you have or save the changes that you have and have a clean dataset. All right. Now this output of datalet status shows you that the directory with the new PDF files is untracked. And this means that it is yet unknown to any of the version control software. So as a first take-home message, this shows you that you need to explicitly give any content to datalet to have it version controlled. It's not enough to simply add it to a dataset. How can we instruct datalet to version control these contents? We save them with the datalet save command. This is the first time that we're using this command, and this is the first time that you need to specify a commit message yourself. So what we're doing is datalet save and then the -m option, to which we can attach a concise summary of what we have downloaded, for example. In this case, I'm just describing the books that I have downloaded. Afterwards, save reports that it has added those books to the dataset, and datalet now knows about the books directory and the 2 PDFs inside of it. If I use git log -n1, I can take a look at the most recent commit in my history, and the information, the way that this information is displayed here, is again something that one needs to get used to if you're not used to seeing Git histories, but you can get used to it quite fast. In any case, thanks to the commit message, we know exactly what has been done by whom and also when. Now, this was already really easy just to save. So you already know how to version control content with datalet. Let's work on some best practices just because this was so easy. You might have noticed that the datalet save command that we just ran saved all of the untracked changes that were present in the dataset. And this is the default of datalet save. Datalet save, if you don't specify anything else, will save all of the untracked modifications or unsaved modifications in your dataset. And that's behavior that's sometimes inconvenient. One great advantage of a dataset's history is that it allows you to revert changes that you're not happy with. But this is only easily possible if the units are single commits. So if one save commits several unrelated files or changes, then those are hard to disentangle if you ever want to revert some of those changes. But if you provide atomic changes that are one meaningful unit that can be reverted without affecting any other change in your dataset, then you're good to go. So how can you do this? One way is to specify precisely which files you want to add. And this can be done by simply appending a path to the datalet save command. We can show you how this is done by simply downloading another book. First, again, we download it, then check the state of the dataset with the datalet status command, and then we'll save it. So datalet status shows that it's an untracked file as expected. And if I now want to demonstrate precisely how to specify this exact file to be saved, then it's a datalet save, an informative commit message, and a path to this new file. Awesome. Before we move on to the next demonstrations, let's take a look at files that are frequently modified, for example, code or text. To try this or to show it to you, I will create a file and modify it. In the context of an educational course, I will create a file which collects notes on the educational course Datalet 101. So I'm just creating a file where I frequently write notes about the datalet commands I'm learning into. The way I'm writing these notes is a bit convoluted because I again want to do everything inside of the terminal. And this is why I'm using here docs. This is a form of Unix redirection to paste text into a file. So the first note that I'm writing is just this middle of the line I'm executing. So it's one can create a new dataset with datalet create path. The dataset is created empty. And executing this line will write this to a new file, notes.txt. You can also just open up any editor of your choice and then just write the notes in any way that you would usually write notes or text. Now a datalet status will, as expected, report this file as being untracked. And we can again save it with a datalet save command and a helpful commit message. Because this file is the only change that's present in the dataset, I don't even need to provide a path. Let's now add another node to modify this file that is already version controlled. Again, I'm doing this here with a here doc. The next datalet status report does not report this file to be untracked, but because it differs now from the state that it was saved under, it is reported to be modified. And how can I save a modified file? Again, with datalet save. If I take a look at the history of this file now, again with git log, then the history neatly summarizes all of the changes that we have done. This means that taken together, local version control is really easy with datalet. It requires a dataset, and afterwards all of the modifications that you do to this dataset can be saved regardless of the size or type using datalet save. If you save only meaningful units of change and attach helpful commit messages, then it will be easy for you to create a dataset history that you and your future self and others can understand right away, and that you can also interact with well. Cool. So to summarize everything that has happened so far in this train track, here's a short overview. Datalet create creates an empty dataset. There are useful configuration options. You've seen text to Git. There will also be Yoda that apply suitable defaults to your datasets, and you can read up on all of the details on them in the Datalet handbook. Dataset has a history, and this history is used to track files and the modifications done to them. You can explore it with any tool that is able to explore Git log. My personal favorite, for example, is TIG, T-I-G. That gives a really nice, beautiful, visually pleasing summary. Datalet save records the dataset or file state to the history of your dataset. And if you attach a concise commit message, then your future self and others will thank you for this human readable information that makes your dataset history understandable. Datalet status is a command that you will frequently run because it is a command that reports on the state of the dataset. And just to reiterate, a clean dataset status is good practice. So always try to have all of your changes saved at one point. Cool. So just by using version control, you can already improve your work greatly. You will work more cleanly, you'll have less cluttered directories, and you'll also have the safe feeling that comes from the certainty that no changes that have been added at one point to your dataset can ever be lost. That's quite nice. Oh, they cuddle. All right, let's get to the next topic in this demonstration, consuming datasets. There are many awesome datasets out there that you can install on your computer. For example, we have public datasets with hundreds of gigabytes of openly shared neuroscientific data that you can use for your analysis. All of the datasets on OpenNeuro, for example, are available as Datalet datasets. And I can show you now how to install a Datalet dataset. The educational course does not download a dataset from OpenNeuro. Seminars, sorry. First, I again will create a subdirectory in my dataset for this to keep everything nice and orderly. Here I'll call it recordings. Afterwards, I install the dataset that I'm interested in. This can generally be a path or it can be a URL. And if you check out the Datalet handbook, then you can find many more sources. I will provide its URL to the Datalet clone command. Importantly, I'm also attaching a path at the end of the Datalet clone command that points to the directory where I want to install this dataset in. That's the new directory I've just created. And also importantly, I'm installing this dataset as what is called a subdataset of Datalet 101. In other words, I will nest the two datasets, Datalet 101 and the LongNow dataset into each other. Then I have a super dataset and a subdataset. And this is done by providing a -- dataset flag and a path to the root, in this case it's just a dot, to the top level dataset. Here's how this subdataset looks like right after I cloned it. There are new directories in my Datalet 101 dataset, and if I navigate into these new directories and then list the contents of one of it, then there are hundreds of MP3 files. And given the amount of files that we're seeing here, it is really quite surprising how fast the installation of the dataset was. I personally would expect that it should take much longer to download a directory with that many files. But here's the crucial and incredibly handy feature of Datalet datasets. At this point, right after cloning, the dataset only contains small files, for example, the README files, and what we simplify or refer to as file availability metadata. All of these MP3 files that you can see in here don't have any file content yet. Think of them as only being file names, but not having content. So if I would try to play one of the recordings, then this would fail. Here I'm trying to open it up with the VLC player, and you can see that the poor tool complains that it just can't find the file that I want to open up. This is weird to get used to, but incredibly handy. This makes this dataset really lightweight and fast to install, but because I can still explore the hierarchy of the files in this dataset, I can check what is available. So let's take a look at the size of this directory. I'm using the du command to show the disk usage. And this dataset right after installation is tiny, because I've told you file content is not available yet, only small files. But I can also find out how large the dataset would be if I would get all of the file contents. And for this I can use data.let status with the --nx flag. So in total, it appears that in this dataset would be more than 15 gigabytes of MP3 files. And because I've installed this dataset, I now have access to these files should I want to. File retrieval, that means getting the file contents actually down to my computer, is done with the data.let get command. This command can retrieve individual or groups of files, directories, subdatasets, whatever you specify, and then download their contents. I will do it for one podcast title, and you can see how it summarizes the operation in the end with a OK to indicate that successful retrieval happened. Afterwards, I can actually open up the file content, and it is now locally available. So I can now listen to my podcasts. And if that would be an open neuro dataset, I can analyze the neuroimaging data I have just downloaded. If we retrieve more files, including one that was already retrieved, so I'm retrieving 3 files in total, but one of them already has the content locally available, then you can see that it is not re-retrieving the already existing content. It will summarize this file to be not needed, and the other one's content is retrieved. Cool. Now, imagine that this dataset wasn't about podcasts, but, for example, the Human Connectome project. We make the HCP data available as a dataset that you can install from GitHub, just as you have with this podcast repository. That makes it very easily accessible. When you clone this dataset, then in its entirety, with all of the subdatasets that the HCP dataset that is on GitHub has, it will have 15 million files and 80 terabytes of data. And that's a lot to store on a single computer. However, if you take into account the features that data-led datasets have right after cloning, you realize that even though you have access to all of the 80 terabytes of HCP data, the dataset that you have downloaded will be incredibly tiny. And you can download only those files that you are currently needing, because probably your analyses of the HCP data will not require 80 terabytes of files or all of the 15 million files, but maybe just a subset of them. Cool. So this is already a disk space saving approach to things. By still having access to all of the data and only retrieving that data that you currently need, in theory, you can have more data on your computer than your hard drive has available disk space. That sounds cool, doesn't it? And we can take this further because now imagine that you have run an analysis on the HCP data. So in theory, only your results are what is important. You can always re-download the HCP data, but your results are unique and you should save them. Let's take a look at this in our narrative. So let's say that you've listened to a podcast and thus you don't need the content anymore. Then you can use the command data.let drop to remove the content. In its place, after you've dropped the content, there will still be the file name, so to say, but no content, just as it was right after you cloned this dataset. And because datalet knows where to get the data from, it can just be re-retrieved. So if I run datalet get again, then I have downloaded it again. That's quite handy. Note though that dropping and re-retrieving data does only work for data where datalet knows the origin. So you can drop data from installed datasets, for example, and data that you have attached origin provenance to, but you shouldn't attempt to drop data that you've just added to your dataset, because this operation would permanently remove the content from the dataset, and datalet get will not know where to retrieve those files from. So don't drop the PDFs that you have added to this dataset. Should you attempt to do this, datalet will warn you though and not let you proceed without forcing. Cool. So at this point, you have the means to version control arbitrary large contents, and you can consume existing datasets, and you can save disk space by getting or dropping data on demand. One other aspect that is useful to understand is dataset nesting. Let's take a look into the history of this LongNow subdataset. We can see that it has preserved its history completely. There is no notion about PDFs or nodes that were created in the Datalet 101 dataset, but here we can see the complete evolution of this dataset. I can find out who created it and what was done to it. This means that this dataset has kept all of its provenance. How does the addition of the subdataset look like in the top-level dataset? If we query the Datalet 101 history, then there also will be no of the commits that we have just seen, no commits about MP3 files, or any of the other commits. And instead, we can see that the super dataset recorded the LongNow dataset as a subdataset. This means that it recorded where this dataset came from. So here it is its GitHub URL and what version it is in. Do me a favor and memorize this commit charsum that is referred to as subproject commit here for a short time. At least the first few characters of it. I'll navigate into the subdataset again, and here we notice that the charsum that we have memorized is the charsum of the most recent commit in the subdataset. So what the super dataset recorded is the most recent version. And thus, by nesting datasets, you have a way of linking a dataset in a precise version to another dataset. Let's quickly summarize everything we have seen on dataset consumption and nesting. You can install a dataset using datalet clone, either from a path or a URL, or if you read the handbook, also from a range of other sources. In this example, we have seen a dataset being installed as a subdataset inside of an existing dataset by specifying the --dataset option, and a path to the root of the top-level dataset. But you can also install datasets on their own outside of existing datasets by just not using the --dataset option. Right after the installation of a dataset, it is really lightweight. There are only small files and metadata about file availability present, and you can retrieve any data that is not yet present using the datalet get command whenever you need it. If data doesn't need to be present locally anymore, then you can drop it using the datalet drop command to save disk space. And finally, datasets preserve the history. Thus, I can find out things like what was done to a dataset, how did a file came to be, or who did work on this, and much more. And when nesting datasets, the top-level dataset or the super dataset records the version that this subdataset is in. But now, what makes this last point so special? It's sometimes a bit hard to grasp if you have these simplified examples. In principle, it allows to join independent components for, say, a study. Let me give you a concrete example of this to make it a bit more clear. For this, I'll briefly abandon the handbook narrative, and instead I'm showing you a paper that I have written. Thanks to DataLad, this paper is completely and automatically reproducible, and I'm able to share code, data, manuscript, and code execution on GitHub. So if you want to, check out the GitHub repository in this link and try it out yourself, or read all about the details on creating such a reproducible paper in a dedicated use case in the DataLad handbook. This repository is a dataset that I published to GitHub. The top-level dataset contains the LaTeX sources for the manuscript and the code that computes the results I report in my paper. The dataset also contains sub-datasets that contain the various data that this code is executed on. And I set everything up in a way that figures and results can be computed locally and are directly embedded into the manuscript after the computations have ran. With such a repository, I can not only share my code and data, but everyone can simply recompute every result of my paper and validate its claims. And all of that openly available on GitHub. That's quite neat. So what happened while I wrote this paper was that data for my computations changed because a mistake was fixed. With DataLad, though, I was able to simply update the data to its fixed state and record which version of the data my computations are based on. Let me show you this in a bit more detail. This way I can also show you how cloning nested datasets feels like. So to dive into this, I cloned this dataset from GitHub. Afterwards, I can check out the subdatasets of the top-level dataset. I can do this with the command datalad subdatasets. This lists all of the available subdatasets of the current dataset. One of the subdatasets is called Remotnov, and that's a dataset that contains the source code for a Python package called Remotnov used in eye tracking analyses that this paper is about. Now, after cloning a dataset, its subdatasets will be known, but just as content is not yet retrieved for files in the datasets, subdatasets of datasets are not yet installed. So if I navigate into an uninstalled subdataset, it will appear like an empty directory. You can see that if I list the contents, there's nothing. In order to install a subdataset, I again use datalad get. This command doesn't only retrieve file content, but it also installs subdatasets. So if you want to be really lazy, you can just run datalad get -- recursive and then -n in the root of a dataset to install all of the available subdatasets down the hierarchy of datasets. The -n option prevents data from being downloaded. It is short for -- no data. The recursive option recurses into the hierarchy of all of the datasets. And here I'm limiting how deep I actually want to install datasets because this dataset is really quite nested. Okay. Afterwards, I can again query which subdatasets are available. Now in the Remotnov subdataset, and here I can see, oh god, there are even more subdatasets in this dataset here. Those subdatasets contain data that is used for testing and validating the software performance. And at this point, you really might be sick of seeing subdatasets. Because what's the point, I guess? Well, what is very useful is that subdatasets modularize my paper project. And keeping things modular can make project components more reusable and the overall project less cluttered and more understandable. And by nesting the modular components, I can flexibly link everything that I need for a given project, while each component preserves all of its history and provenance. For example, the top-level dataset contained code and manuscript for my paper. This is one standalone component that is useful. Another subdataset contains the data that I'm running the code from the super dataset on. This data can be used in more than a single paper though, so I'm keeping this as a standalone dataset and just link it in a precise version to my code and manuscript. This way I can use the dataset easily for all kinds of analysis simply by installing it into the dataset that I currently develop my code in. the Romotnov subdataset contains the Python package that the paper is about, and this on its own is again a nice standalone thing. And the validation data that the software uses is again also used in several contexts, and there's also standalone datasets. Now, because all of these datasets are linked as a nested hierarchy of datasets, if I share my paper with you, you can go from the finished paper back to the raw data that I base my analyses on and get a complete overview of what I have done should I decide to share all of that. And this aids the reproducibility and transparency of science greatly. I'll elaborate on the principles behind this a bit more later, but let me first show you how, in general, important it is to version data and link precise dataset versions. One of the validation data subdatasets came from another lab that shared that data. And after I was almost finished with everything and was writing the discussion, I came across a paper that reported a mistake in this shared dataset. I checked, and the mistake was still present in the data that I was using. So if you go into the history of this specific subdataset and check it out, then you can see that at one point I contributed a fix that changed the data. The data is now fixed, but this nevertheless means that there is a difference in the data that existed in 2018 and the data that existed in 2019. And changed data is a very dangerous thing to the reproducibility of science, because changed data usually also means changed results. But because everything here was linked as data-led datasets, I was simply able to update the data to its most recent state, and then rerun all of my computations automatically, embed all of my results automatically, and have correct results based on fixed data. And if I wanted to, I could even go and check, for example, how robust my results are against mistakes like that by resetting this dataset to a previous state and then rerunning everything again. So having data-led version data is, from my personal experience, a really useful thing to have, and a great protection against unknown changes in data that can make data potentially irreproducible if you're not aware that your data changes. Cool. This has hopefully given you a first idea on why nesting datasets is useful, why version controlling data is important for the reproducibility of analyses, and how complex but yet surprisingly understandable data-led datasets can be combined to publish reproducible research objects. And that already brings us to the next part of this demonstration: reproducible analyses. Not only can I version control data and consume data with data-led, I can also create datasets with data analyses in a way that my future self and others can easily and automatically reproduce and recompute what was done. And in order to do this, I actually don't need to do much. I need to comply to some basic organizational principles for datasets, and I need to tell data-led to record how analyses are conducted. The results of such an effort will be a dataset that has a provenance record on how results of an analysis came into existence. And it also has the ability to automatically re-execute an analysis. And I'm going to show you how this is done. But first, let me give you a wrap-up of these basic organizational principles I talked about. If you're interested in the details of them, then you can read up on them in the Data-led Handbook in the chapter on Yoda principles. You will also recognize them from the setup of the reproducible paper repository that I have just shown you. So, first of all, you should make sure that your dataset is clean and modular. The analysis code should be developed in the top-level dataset, and the input data for the analysis should be installed in its precise version as a subdataset, for example. So you have the code component and you have the input component separate, yet linked as datasets. Next, you shouldn't touch the raw data. When you compute results for a data analysis, don't save them into the input dataset. Instead, keep the subdataset clean and untouched and collect the outputs in the top-level dataset. This makes it easier to understand your directory structure. So if you include outputs and inputs into the same directory, it will be hard for others in your future self to understand which is input, which is output. But importantly, adding the outputs to the dataset that you computed your or developed your code in and ran your code in will also help you to link your results to the code and the computation. Further, keep super datasets self-contained. Write scripts that reference subdatasets or files with relative paths instead of absolute paths. This way you can share your dataset and the scripts will run successfully on other computers that have a different underlying file structure if they only reference files or subdatasets as relative paths. And finally, you should record as much provenance as you can. So you should link datasets by installing them as subdatasets. You should record the execution of commands to track which scripts produced which output, or even attach a software environment to the execution record. And if you adhere to these principles, then you can create data analyses that can be automatically and even computationally reproducible. I'll show you the basics of this in a small data analysis project in which I will run a simple classification analysis on some dataset. This is a toy example, and it's simplified to make my life easy and to not have you bother with understanding the computation, but the principles that I'm showing you can be applied to a dataset, to a data analysis of any complexity. So here, what I'm doing, I'll take this very known iris dataset and run a simple k-nearest neighbors classification on it. Importantly, in this analysis, I will make sure that I not only record how I run the computation, but I will also make the computation automatically reproducible. But first, let me set up my analysis. For this, I create a new dataset. Here, I use a different configuration procedure that is called Yoda. This configuration sets up a helpful structure for my dataset with a code directory and some README files, and it applies helpful configurations. Next, I will proceed by installing my input data as a subdataset to keep everything nice and modular. For this, I created a dataset with a CSV file that contains the iris data, and I published it to GitHub. Here, I'm installing it into a directory that I call input. The last thing I need is code to run on the data and produce results. For this, I have posted a k-nearest neighbors classification analysis script that I'm currently printing to the screen and then save into a script.py file in my code directory. This script is written in Python, and it uses the package pandas to load the iris data, the package cborn to plot the data and then save a figure as a result, and the package sklan to perform a k-nearest neighbor classification and save those results. I have also, as you can see, included a datalet-get command in this script, just for you to see how datalet can be used in Python scripts. And what you should note here is that all of the paths that I'm using in this script are relative and not absolute. So they only point into, for example, the subdataset or to the root of the super dataset. I have copied the script into the code directory and running datalet status tells me that it is unsurprisingly untracked. So let me quickly save it to the history of the dataset with a datalet save command. We can also pretend that this script is really complex, and I have spent weeks working on it with plenty of datalet saves in between. If I want to, I can also identify this finished state of my analysis script with a tag, an identifier. I can attach this with the -- version tag option of the datalet save command. Now with my input data installed and with my code script set up, I can in principle now run Python, so interpreter, code script.py to execute the script and produce results. But if this script or this analysis would be more complex, or an analysis of one of many, then it will be bloody difficult to associate the outputs with the script that was run or with the data that it was run on after, let's say, 2 days. It's very hard to remember such things. And the challenge that datalet helps me to accomplish is to run the script in a way that links the script to the results it produces, and also to the data that it was computed from. I can do this with a specific command that is called datalet run. I'll visualize it here, and I'll walk you through the figure in a bit. Datalet run, in principle, is a command that captures the execution of any command, the execution of a script, the execution of a terminal command, and then links the command that was run to the output that was produced. So it takes the dataset state before running the command, then runs the command, checks what changed in the dataset, and saves all of that, linking it to the command that was run. So if I'm running a script, I can link the outputs that are produced by this script to the script and the command I called it with. In principle, this is really simple. So let's start. First of all, we need to have a clean dataset. Afterwards, I'll compose my datalet run command. I give the command that I would execute, in this case Python code script.py to datalet run. And datalet will take this command, run it, and save all of the changes in the dataset that this leads to under the commit message that I have specified with the -m option right at the start of this command. So this already associates the script with the results that will be produced from it. But the command can even be more helpful. It can also help to retrieve the data that is necessary. So I can specify the input data in the command, and datalet will get the data beforehand, because even though I have installed this sub-dataset, I haven't retrieved the data that is inside of it. Here in this particular command, I also specify the output of the command. In principle, this is not always necessary, and to understand fully what this does, please read chapters 2 and 3 of the Datalet Handbook. But in general, specifying these outputs will allow me in a couple of minutes to rerun the command and let me update outdated results. Now, if I run this, Datalet creates a commit in my history. This commit has the commit message that I gave to this commit as a human-readable summary of what was done, but this commit also contains the produced output, so it's already linked. And importantly, the commit has a machine-readable record that contains information on the input data, the results, and the command that was run to create this result. This machine-readable record is particularly helpful. So it's not the most readable thing, but it's not meant for human consumption. It's meant for machine consumption. Because now I can instruct Datalet to rerun this command so that I don't have to memorize what I had done And the people that I share my datasets with don't need to ask me how a particular result was produced. They can simply let DataLad tell them. And re-executing a command that was ran through DataLad run is done with the DataLad rerun command. For this demonstration, I have prepared an analysis dataset and published it to GitHub, just the same analysis dataset that I have created with you right now. And now let me simply clone this repository and then use the DataLad rerun command to rerun the run command that I have used. So imagine that I'm a collaborator of myself. I received this dataset, I want to find out what was done, and I'm simply rerunning the exact computation. For this, I could use something like a tag, but here I'm just checking the checksum of the run commit and put it into the DataLad rerun command. DataLad will then read the machine readable record that is attached to this commit identified by this checksum and then recompute the exact same thing. Because I have specified everything that was necessary, the inputs and the outputs, DataLad will be able to retrieve the data and update the outputs, for example, should the data change, and so forth. And now I have reproduced the results that I computed here. Cool. So this allows others to very easily rerun my computations. But honestly, it also spares me the need to remember how I executed my script. I have scripts that have many command arguments, and sometimes I really can't remember how to execute them. And if I execute them with DataLad run, I can simply rerun them and have DataLad take care of this memory task for me. And that's really helpful. What I could also do now is I could alter my script a bit, for example, change the color scheme of the figure that I have created, and then simply rerun the command again to update the figure to a new color scheme. What is also useful in this dataset is that I can simply ask a result where it came from. And this can be as simple as just running the git log command on this result. And afterwards, the git history of this command will tell me all of the commits that are associated with it. So with this very simple information, I can find out which script produced this result on which data. I can even find out on which version, and who did this and when this was done. Very useful if I ever want to blame someone for a particular computation, for example, myself. Cool. But let's now take reproducibility one step further even. Let's say that I share this dataset with you and I want you to recompute my results. If you, however, don't use Python regularly and don't have the required Python packages available, running the script and recomputing the results will naturally fail because you don't have the software available. In order to be computationally reproducible, I also should attach the software that is necessary for a computation to this execution record. And this is particularly helpful if you're using software where different versions of it produce slightly changing results, or if it's software that's just a pain to download. So if you want to spare others the pain of setting up their software environments just so that they can recompute and validate your results, do them a favor and attach software environments to your computation. And the way I can do this is with a DataLad extension. DataLad has several extensions that come with special functionality and add DataLad commands to the commands that DataLad core already has. In this case, the DataLad extension is called DataLad containers. You can install any DataLad extension with the Python package manager pip. So in order to install this extension, I can simply run pip install DataLad containers. This extension is really helpful because it allows me to attach software containers such as Singularity or Docker containers to my dataset, and then it will execute the commands that I'm running inside of these containers. With this, I can not only share my code execution and my data, but also the software that everything runs in. And here's how it works. First, I attach a software container to my dataset using the data-led containers add command. This command takes a name of the container, here I call it software, and a URL or a path to where this container can be found with the --URL flag. You can have a container locally and then point with a path to it, or as in my case here, point to a URL on Singularity Hub or also Docker Hub. And what this command does is it records the software in the dataset. So you can see that the container is currently being downloaded and then saved into my dataset. Afterwards, I can rerun my analysis in the software container using the data-led containers run command. This containers run command works just as the run command before. I only need to additionally specify the container name. So if you now were to rerun such an analysis that was run with data-led containers run, data-led would not only retrieve the input data, but it would also retrieve the software container and then execute the command with the code that you provided on the data that is recorded in the execution inside of this container. And thus, you can make sure that your analysis is as reproducible as you can potentially make it. Cool. So to summarize this last demonstration, data-led contains functionality to create reproducible analyses by linking data, code execution, and software to the results that it produced. This helps others to understand and recreate your analyses, but it will also be helpful for yourself to produce your own results and keep track of what you have done. I hope that this demonstration gave you some interesting glimpses into the basics of data-led and what is possible with it. There is a lot that I didn't explain yet, and there is much more that you can use data-led for. All of this is detailed in the data-led handbook though. So if my demonstration intrigued you and you want to find out more, then go ahead and read the data-led handbook, check out the pieces that you need, and learn how to do the project that you envision. You can, as a start, also, for example, clone publicly available datasets such as the ones from OpenNeuro to just explore datasets a bit more and explore the looks and feels of them. If anyone is still listening at this point, thanks a lot for your attention. I'll finish with acknowledgements and with many thanks to the creators and contributors of data-led and the data-led handbook. If you have questions, then reach out, for example, in the data-led Riot channel or on GitHub of data-led or of the data-led handbook. And if you want to, you can contribute to the development of the data-led handbook, for example, with your own use case or by simply making the book more accessible or understandable. I appreciate everyone who reaches out. I hope that I will be able to meet you in person, tell you more about data-led face-to-face, and in general that we all get safely through this pandemic. I wish you a happy further train track, and if I'm here in this train track session, then bombard me with questions about data-led. Bye from my side, and see you in the chat.
less time for the math lab session than was necessary for that session. That was primarily the main reason. So yeah, I mean, we had initially thought that session would be about an hour and a half, and it was closer to 2 hours. So that was the main delay, but also inevitable technical glitches, moving people over to a new event within Crowdcast, etc., that sort of thing. But tomorrow we will really try to stick to the schedule. Tomorrow, I would say that the main source I can think of for a delay in wrapping up will be the very last session where everybody's going to give updates about their projects. As you all saw yesterday, we have about 22, something like that, projects in this hub, I think in addition to the cross-hub ones. And so I imagine that the hour and a half that we dedicated to that might not be sufficient, but we'll see.
Stay tuned.
Yeah. So.
And we appreciate the patience.
Yeah. So there's another question. Can we find all the links shared today during the training sessions in one place? At the moment, so there's a train track page on the website, and so for every single topic, you can click on that, and then you get a modal pop-up window. And there we have a bunch of different links. So for the COMP session, there's actually an embedded video, and we will. Do you want to say how long the updates should be? Probably 5 minutes max. I mean, if you if you guys manage to accomplish an insane amount of stuff, then of course, take a bit more time. But I think on average 5 minutes. And yeah, so for the train track content, yeah, so there will be like a modal pop-up window for every single topic. And so there, for some sessions, you have like embedded videos already. We might be adding like the pre-recorded videos there as well. Then there are also links to websites and other resources as well. And so for Bids and Bids apps, I created a HackMD document today. And I guess we can do the same thing and just like pin it in every single help desk channel if that's something that people think would be helpful.
Also remember that there's a document for small jobs for people that code very little or don't code.
Yeah.
And we'll just post it here. But yeah, make sure that you check it out. Some people are looking, from project leaders are looking for anyone who wants to do something like making a logo, etc. So that way you can contribute.
Yeah. Does anybody have any other questions or comments or wants to come on screen?
If not, you can go to Gathertown after this and have a drink, a bagel, I guess.
Yeah. How's your experience been as a co-host?
It's been interesting, I would say. I guess, yeah, it's fun. It's fun though. It's just hard to keep track, to actually go to the to the train tracks, for example, to pick things up. But luckily, we can check that out later.
Yeah, for sure.
Yeah.
I mean, that's the beauty of the pre-recorded videos.
Yes.
Well,
so, yeah, but it's quite a good a good experience, I would say. Yeah, it's really great. So if people don't have more questions or comments, then we can just wrap it up and maybe go to Gathertown or.
Yeah. I guess if any project leads are feeling particularly excited about what they've been working on, then you're welcome to come on stage now. Where are Lisa and Eduardo located? So I was supposed to be in Montreal still, but I'm now in Brooklyn, New York.
Yes, I'm in Querétaro, Mexico. I'll just write it down there.
What is Lisa's most frequently hummed tone? I don't know. I just make random sounds. I'm sorry. I'm awkward. I apologize. I think I didn't even realize that I was humming. I caught myself and I said, really should stop doing that, but I am sorry.
We're not professionals.
We're not in the slightest. I don't even like speaking in front of a large audience. So like, I've been trying to figure out if I actually prefer this, the fact that people can't see me. I don't know. I feel like maybe it'd be easier if I could actually see the audience.
Plans to socialize.
Any plans to socialize with the APAC people over their morning coffee on Gathertown later? Yeah, you're welcome to do that. I mean, the Gathertown is accessible to everybody registered to the Brainhack event across all 3 hubs. So if you have time, if you want to, you are very welcome to do that.
Yes. Yes, you can do that. You can go socialize, whatever. You can even be in the talks if you don't sleep.
Yeah. Attend all 3 hubs if you want to. I'm kidding.
Yeah.
Don't do that. Make sure to eat. Make sure to sleep, please.
Yes.
Don't be a rummy go. Actually, try to sustain yourself.
Yes.
Thanks, Christine.
Thanks.
Christine, do you want to come on screen? You could tell us more about CONP if you'd like. I'll invite her. So I was in the same lab as Christine for my master's.
Okay.
Let's see if she accepts.
So I guess there's also the feeling that when you ask me about the co-hosting is that there's a lot of people that know each other here in this, like the Brainhack.
Yeah.
I'm new, so I know very little. So I guess a lot of people also feel like that in this Brainhacks, right? But that's how you meet people.
Sure, for sure, yeah. It says accepted and connected. Yeah, I will say that for me, I think coming from Montreal. Hi, Christine.
Hi.
Montreal has literally such a massive open science community. I mean, Christine can attest to this. I mean, when we were, when the event was supposed to take place just in Montreal and we were going to limit it to 170 people, I said, we can easily just get 170 people from Montreal alone.
I know, and I'm like, oh, who's talking? That sounds like Aga. Oh, it's Aga. Hi, Aga.
Yeah.
But it's amazing because we have these open science beers going in Montreal every Wednesday, and it's like, I miss you guys anyway. Let's meet online anyway.
Yeah.
But yeah, it's hot here. Does anyone want to meet by the pool for a drink and a swim and the gather? No? I was just going to say, Lisa, thank you for announcing it. From Samir and Tristan's comp demo earlier this afternoon, there were a lot of questions, which was great. And there were also a few more things that, like the screen sharing didn't work, so we just figured we'd do a Q&A follow-up. Tomorrow at 2:30, I'll put the Zoom link in. It's already in the unconference list. Find us in Mattermost, and the Zoom link will be there. But just because there was all that energy and questions, and there's no reason not to keep talking about it if people have questions. It's going to be right after the big machine learning session that presumably everyone's going to be going to. So right after that, hop on over and we'll keep talking about the Canadian Open Neuroscience Platform if people are interested. So that was just the idea.
Cool.
Yeah, and shout out to you hosts, by the way. Can everybody recognize this is not easy, what you guys are doing with such grace and calm, hours, and all the digital inputs. There's only 26 channels you have to keep on at the same time. So, point to you day after day after day for the hosts for being just on it.
Thanks, Christine.
Thanks.
I was gonna say I'm clearly making a fool of myself, just randomly humming and not even noticing it.
We're trying to not implode.
Honestly, you know what? This hackathon is not just going to be remembered for the project; it's going to be remembered for those rabbits and Lisa's humming. So, all the Easter eggs that you can lay in this whole event, all the better.
Speaking of Easter eggs, one thing we were thinking about is it would be really cool if we could have actual Easter eggs or a treasure hunt in Gathertown. But I don't know if we could add that.
Somebody can find a way. Who's going to be the most likely person to find a way? Is it going to be Remy?
Is it what?
Is it going to be Remy?
So it's Johan who set everything up. So maybe Johan. I don't want to put any more work on anyone's plate. So we've sort of stretched our volunteers very thin at this point.
It's true. Does Johan need any help in adding Easter eggs?
Yeah.
That's Johan. Call me, okay? Yeah. Also, what is this Yarek is saying about 100 people are from Montreal, and is that a question?
There are not 100 people from Montreal. I'm pretty sure about that.
You could easily get 100 people from Montreal.
Yes. Yeah.
4 universities, all the good stuff.
Yeah.
Yeah. What is actually? What's the breakdown? How are we doing in terms of people from up and down the East Coast here? And
Oh, I'm not sure actually that we've collected that data. So there's over 400 people enrolled across like all 3 hubs.
yeah,
So this hub has the most people. I think we were at a bit under 200. I think something like that. I think that the Europe, Middle East, and Africa hub had somewhere between 100 and like closer to 150, and then I think the other hub had somewhere a little bit under 100.
okay. And the Pacific Hub includes California people too, right?
No.
Mostly Ashley Asia Pacific. Okay. Sorry, I should have known that. But okay, so what you're saying is that we should definitely go check out their social hours, like right
Yeah,
now.
definitely. Yeah.
Right now.
Yeah.
Yeah, I
Right
mean,
now.
they're
I mean,
like
all the
sessions.
leadership here. But
Oh
yeah.
my God. Chris said we've also been overrun by Germans. This is
How do
true.
you define overrun, really?
2 people, Adina.
Two people and an equal number of rabbits? I don't know if that counts.
Oh, that's hilarious.
I don't want to throw any grenades, but you guys can do better. Like, you come on, we can cross pollinate, because I think that's the thing about hackathons that everybody's really missing too, is just meeting people you never normally get to meet in your time zone.
Yeah. I mean, that's one thing that we were worried about with having the hubs, that it would be more difficult for people really around the world to meet. But I mean, there's still a lot of time zones within each hub.
Yeah.
So it's not too bad. And I mean, our people in the Europe, Middle East, and Africa hub can pretty easily join in during their evenings because what's been happening. That's how I guess Adina and Michael are still here. Thank you both, by the way, for still being here and for answering people's questions. We really appreciate it. Yeah.
Cool.
Sorry?
No, that's good. Dorota has a very valid point. Now I feel like I'm on a podcast. So maybe I should see you guys over by the pool in the session.
Yeah.
But thank you for inviting me on for this, my very first hackathon guest spot.
Yeah. All right, bye, Christine.
Take care. Oh, remember tomorrow there's a session after the wrap up. There are beers, right?
Yes. Yes. So I think we'll be sharing more information about that later today.
Yeah.
I can do what I did yesterday and just select a person to join. I don't know if anybody else would appreciate being called out like that, but I have zero qualms doing that. I wonder how many people will just leave.
Right now. I think it's at what time do we finish the wrap up?
Great question.
I mean, in my time it's now, but
now. So I guess we can end and we can just go to GatherTown.
Yeah, sure, whatever.
Yeah, I guess we'll do that then if nobody has any more questions. I guess last chance to ask us a question here.
Comments, questions, otherwise have fun.
Criticisms, suggestions. If you want to come on stage and sing a song, you're welcome to do that. I'm a terrible singer, so I'm extra apologetic for my humming, but if anybody else is a good singer, you're welcome. Nope. Okay, well.
Please don't.
Eduardo, can you sing?
No.
Okay. I guess we should probably just end this now and then we can see people in GatherTown.
All right.
All right. Yeah, so thank you all for joining for the second day of the Brainhack, and we will see you either in GatherTown or tomorrow morning.
Thanks, everyone. Take care.
Bye.
Bye.